Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So it gives me pleasure to introduce Christoph Swalina from the .NET team. Christoph was originally responsible for the design of a third of the .NET framework APIs, such as collections and stuff like that. And so he worked with Anders, to put that together all those years ago. Currently now, in addition to current development of like WinFX APIs and stuff like that, Christoph's also doing reviews of other API sets within the company and is responsible for versioning and that kind of stuff within the .NET framework. So thank you, Christoph, for spending time to share your knowledge with us. So I'll hand it over to you. Thank you.
Sounds good. Thank you very much. So as Gavin said, I participated in design of a lot of framework components. And what's interesting, it was right after I joined Microsoft, right after school, joined this VB team working on the next generation of frameworks. And basically within a week, I was asked by my boss, hey, why don't you design APIs to spawn new processes and control processes? And I've heard that when you join Microsoft, you don't start with brewing coffee, but I kind of didn't expect to immediately start designing the next generation of the platform. But what's even more interesting, 2 months later, the .NET Framework team was formed. Our group kind of got sucked into the bigger team. There were some changes, and I became the only PM on a team, maybe 5-6 developers, basically creating the non-GUI specific components for the .NET Framework. And they don't teach API design at schools. So I made my share of mistakes. And feeling kind of guilty about that, I decided maybe I should be writing them down, correct? So we don't have to repeat them in the future. So that was part of what then became the API design guidelines or framework design guidelines. Probably some of you have heard. And it's basically a document now, maybe 200 pages, kind of describing many elements of API design, from naming conventions, patterns, idioms, and so on. So this presentation is based on maybe a bit higher level principles of API design, but I use many of the design guidelines as kind of illustration. So I will be talking about the need for, let's say, simplicity in framework design, and I will illustrate it with several guidelines from the design guidelines document. So one thing you may be aware of is that the guidelines were created for kind of design of general purpose frameworks. So we design APIs for millions of users. 10 million users supposedly use Microsoft development technologies. And when you do research APIs, the goals may be slightly different. But after kind of analyzing what are the high-level principles that make the broadly used APIs successful, we kind of came up with 5 main areas where it's very important to kind of think about in a fundamental way how to simplify APIs, how to understand users of the APIs. There's this saying, I think coined by some engineers at HP, who said that you should design for the engineer next door. And when you design APIs for 10 million developers, that may not be true. I will be talking about the development ecosystem. So when you design APIs, are you designing just your feature area, or are you designing for the broader ecosystem of tools, documentation, and so on? Consistency, of course, very important. And then kind of how to design APIs so they can evolve very easily. So after some of the theory, I will show you a simple process that we use in the .NET Framework team to actually design APIs. Like, what are the mechanical steps that we use? And I will try to leave maybe half an hour for Q&A. So let's get started on kind of the top five things that you should focus when you design APIs. So the first one is simplicity. And that may sound like a cliche, correct? When people talk about design, they say, hey, simplicity is very important, and so on and so on. But I think, yes, it's extremely important. And more importantly, I think people, when they approach simplicity, they treat simplicity as kind of Pride 2 feature, correct? So first I have to design my API, my component to do blah. Like my boss told me, you have to design an API to spawn new processes and control processes. He did not say you have to design API that is simple and can spawn processes, correct? The simplicity was kind of maybe implicit, but after some time designing APIs and reviewing other APIs, I wish it was very explicit, correct? So when we start designing APIs, we should treat simplicity on par with other features. I will have a picture for each of those 5 principles, kind of trying to illustrate or create a kind of mental impression or visual impression of the concept. And the paperclip is often cited as the kind of pinnacle of design, correct? There are many books written about the design of the paperclip, how many trade-offs go into the design, some of them to enable simplicity, correct? Paperclip is very simple. You don't need a manual to use paperclips. Paperclips come with those boxes and they don't have manuals. But they have some drawbacks, correct? Paperclip is not a perfect device. Yet it's kind of overall is the most successful design. Well, this particular one, it's called the gem paperclip. So when we approach design of APIs, we try to make them simple. We quickly realize that requires a trade-off, correct? So as I said, you trade off features for simplicity, and maybe even within the feature you need to make trade-offs. So the way we approach the whole problem space is we divide the problem space into things that are kind of the mainline scenarios. We call them mainline scenarios. Majority of developers will be trying to read a line of text from a file, correct? So we make an assumption like that. And we try to make those mainline scenarios very simple. So this is where the main effort goes in designing simple and consistent API and so on. And then, of course, we have those very advanced scenarios, correct? Somebody wants to start reading a file in kind of maybe asynchronous way, and then in the middle of reading the file cancel because something horrible happened. Well, this is not the mainline scenario. This is very corner case. We still have to support it, so we have to we have to make these things possible. We don't have to make them easy. We don't have to make them simple. And that's we kind of discovered is kind of the first step you have to do when you decide where to focus your API design. And that's very similar to the well-known 80-20 rule, correct? 80% of scenarios can be covered by very small set of APIs. And if you focus on this small set of APIs, you're going to kind of probably optimize your effort best. Another kind of way to illustrate and talk about the concept is the idea of addition through subtraction, correct? Many times when I review APIs and I talk with teams, they say, you know, this API has to be that complicated because it has to enable this very corner case scenario. And sometimes it's actually better to just say, no, we're not going to support this corner case scenario. And the end result may actually be positive, correct? So I've been working with the workflow team on designing the workflow APIs in .NET Framework 3.0. And they started with the kind of very strict definition, mathematical definition of a workflow, and try to implement every single last guarantee that workflow kind of theory talks about through the APIs. But that had an enormous cost in terms of kind of sacrificing simplicity to get the last single feature. And kind of maybe a month into the design process and talking and reviewing, we decided that we can actually trade off very corner case scenarios. I mean, they are interested only from kind of theoretical point of view, not from practical point of view. And if we could not support these, the APIs could become much simpler. So that's what they did. And as far as I know, they are very happy with the decision and think it was a good trade-off. So, so how do you kind of, what are the specific guidelines that we talk about when we kind of consult with teams and try to provide them with some tools, kind of process for applying the 80-20 rule and the addition through subtraction? I say that if I had to choose one single guideline from the whole design guidelines document that I consider the most important, is basically the one about choosing your scenarios and then writing code samples that basically show the code that the users will have to write to implement these scenarios. So we don't start the design process by let's open Visio, create class diagram, what are the entities of the system, what are the operations attributes. We start the design of our APIs by first writing the code samples that we think users will ultimately write. And then from the code samples, part of the kind of full object model, full set of APIs kind of falls out, correct? So if my sample instantiates a type foo and calls a method bar on foo, I know that in my object model I need to have a public constructor. And if I didn't pass parameters, the public constructor needs to be the default constructor. And then I have to have a method bar. And if the method bar takes some parameters, my object model needs to have the same. So after creating the code samples, you can create like a skeleton of your API. And at that point, you can kind of turn back and kind of go back to the more traditional design process using maybe tools or not. Though I kind of consider case tools and in general the object-oriented design techniques to be not well suited for API design. They were invented for situations where you want to design internal implementation of your library or an application so that it can evolve easily, correct? So the main kind of principles of object-oriented designs were, okay, if I change one part of the system, it should have very little, if any, effect on other parts of the system. So case tools and object-oriented design methodologies were kind of optimized for these scenarios. Now, the difference with API design is that you actually cannot change APIs at all, correct? So in the object-oriented design methodologies, the assumption was the only thing that we want to accomplish is if we change this part of the system, we don't have to change some other part of the system. Well, in APIs, you cannot change even the first part of the system. Almost every single change in APIs is a breaking change. Actually, the only changes that we allow are basically additions. So this whole kind of idea of I change one part, it doesn't have effect on the other part, doesn't apply as much to API design. So, and the last guideline kind of talks about, go ahead.
So where did you get the top scenarios?
Where do you get scenarios? Yeah, so that goes back to kind of planning. How do we do planning? How do we discover what is the kind of main area of focus for the next release? And this is very different from release to release. We kind of experiment with different planning processes. And it's also different planning processes are dictated by different, market pressures and maybe different stage of kind of development, different goals for the previous release, and so on and so on. But we go to conferences, we talk with developers, we do usability studies, we, now use blogs to communicate with customers, and they tell us, we would like to have, better integration of our workflow applications with .NET Framework. And customers would give you a requirement, something along the line of integration with BizTalk, and the .NET Framework, correct? And then you analyze the requirement and you say, actually what they want, they would like to be able to code to APIs that provide similar functionality to BizTalk. And then we arrived at the conclusion, well, we will be focusing on a workflow API in the next release. And then once we know that, we say, so workflow for what? What are the scenarios? Is it kind of business workflows, or maybe training applications use workflow engines? And we kind of, it's research based on customers, users, experts in the area, and so on. So the last guideline talks about a very interesting principle for kind of optimizing for simplicity, which is that one of the main difficulties that people have with using frameworks is finding the type that they need to use to implement the scenario that they have in mind. So let's say a user thinks, I would like to read a set of lines from a file. And then they need to try to find the API, and first they have to try to find the type that will allow them to read those lines. This is the single most difficult step in kind of using frameworks that users are not familiar with. So after they find the type, kind of trying to figure out how to use the members, it's not that difficult. And probably the reason is that we have like 30 or, no, maybe not 30, maybe like 15,000 types in the .NET Framework now. So you can imagine you are trying to find pretty much one type out of 15,000. And we provide a lot of help, correct? We have namespaces, so if you, an ASP.NET developer, you kind of know, I will probably not be looking for this type in the WinForms namespaces. But still, it's a very difficult task. And what happens in the most difficult APIs to use is that you have to actually find several of these types. You have to find several types, instantiate them, hook them up together, and then you can start using them. This provides an enormous barrier for developers who prefer the development model where they learn as they go, correct? They don't read documentation ahead of time. They just open the namespace hierarchy in MSDN and try to find the type that will allow them to read the file. If they have to find not one type, but two, it gets exponentially more difficult, correct? And then it grows very quickly to a point where they just cannot accomplish the task. So we formed this guidance that says, if your code samples, you remember you came up with the top scenarios, you wrote code samples, and then you look at the code sample and it instantiates 5 types and kind of hooks them up together before you can accomplish the simplest task, that will be completely unusable API. So it's best to have just one constructor in kind of, for the mainline scenarios, correct? For advanced scenarios, you're not able to have kind of the ultimate simplicity, and it would not be a good API design to provide kind of Swiss Army knives for every single scenario in the whole world. You would be back to the original problem, correct? You have too many types and they don't do what you want. But for the top scenarios, what we call either Swiss, you can call it Swiss Army knife, this component that does everything. Some people call it Franken components, those who don't like it. But keep in mind the idea of having a one type for the common scenarios is a very powerful tool for achieving simplicity. So here's an example from an actual spec of one of the .NET components, and it's a very simple component. It allows you to basically measure elapsed time, and this is actually a screenshot from a Word document showing how we say, for a component like that, we will have a simple scenario that lets you measure elapsed time, and then it shows a small simplification of the APIs that requires a bit one fewer lines of code, and then a bit more advanced scenario of kind of reusing the same instance. And we try to write the scenarios in multiple languages. So .NET Framework is a multi-language framework, and we discovered that it's not extremely common, but it happens from time to time that a sample in one language looks very simple, and the same scenario implemented in a different language is completely unusable. Let me think if I remember. A concrete case would be, so C# allows you to make an assignment and a Boolean expression evaluation inside the while loop brackets. And VB does not, correct? So in C# you can create a while loop and say, you read from a file, and then you check if the result is null, and if not, you basically exit the loop. In VB, you have to it's a bit more complicated. You first have to read, then you have to check the condition, then you enter the loop, then you have to do something, and then you have to read again and enter the loop. So we basically, from time to time, when we feel the language may influence how the samples look, we kind of write them in several languages. So namespaces are another very powerful tool for ensuring simplicity, or at least perceived simplicity of frameworks. Many people consider namespaces to be a tool for avoiding type naming conflicts, correct? And I see it during the API reviews very often. People use names that are already kind of taken by other .NET Framework components. And when I point out, hey, if the user kind of imports both of these namespaces into their project, they will run into conflicts. And then they say, well, but we have namespaces, so they can disambiguate. And I will be showing kind of more examples about how that works. But we consider namespaces to be almost purely for kind of organizing the frameworks for people trying to learn and kind of understand what are the components of the frameworks. Yes, we have some types in the framework that have exactly same names, and namespaces can be used to disambiguate them. But that is never something that we kind of explicitly design. We never say, because we have namespaces, that's how we should design. We should give types the same name. We use namespaces simply to organize the framework. For a long time, we kind of struggled. Maybe we should use namespaces for that, and maybe for several different goals. And the problem is that, and I think it's a general problem with hierarchies. You can have hierarchy. Hierarchies can be only one way, correct? But sometimes you have, so when you use hierarchies for two different goals, you run into cases where, to accomplish this goal, the hierarchy should look this way. To accomplish this other goal, the hierarchy should look the other way. And you run into conflicts, and then people use one goal versus the other. Other people prioritize this other goal higher. So we basically said, we will use namespaces just to organize, so people can understand the framework easier. The second concept is that usually APIs are divided into what we call the APIs for mainline scenarios and APIs for those more advanced scenarios. And we discovered that in many cases, APIs that are more successful, they actually divide these different scenarios into different namespaces. So you have a main namespace, let's say system diagnostics, that provides APIs for the very common scenarios in the diagnostic space. And then we would have system diagnostics eventing that is actually a more advanced version of some of the APIs that exist in the root namespace. So in system diagnostics, the root, we have APIs to do simple tracing, and in Whitby, you can do tracing to the ETW through some simplified APIs or API abstractions. And then system diagnostics eventing provides APIs for the kind of full richness of the ETW APIs. And not all namespaces do it. Those that do became more successful in terms of kind of simplicity and approachability. So this is another example of networking APIs in the framework. So networking APIs are extremely complicated. For those of you, probably many of you know the APIs very well. For example, the sockets, the full Win32 socket APIs are extremely sophisticated and have a lot of control and so on and so on. But that's not what majority of users need in daily development. So the networking team divided their namespaces into kind of the socket-related namespaces into system.net, which contains web client class. And web client is the Swiss Army knife, correct? It allows you to do some very simple socket-based interactions. And then systemnet.sockets is the kind of full-blown socket networking API with all the bells and whistles. And then there are some other namespaces for mailing and so on. So naming. In kind of historically in many frameworks and APIs, correct, people optimized for short names. And long time ago, I think there was actually a technical reason for it, correct? You wanted to save memory when compiling and whatnot. Later on, it seems that it became basically, this is how we've done things for ages, let's continue doing it. And I think it was also partially kind of the phenomenon of designing for the engineer next door, correct? Abbreviations work for me, they will probably work for everybody. But we discovered that that is not the case, correct? Our users are not and will never be experts to the same degree as we are on the technologies that we produce. So for us, many acronyms, abbreviations seem completely natural. For the majority of the users of the framework, they are not. They are very annoying. And people like clearly spelled out names in the identifiers. And today with the development of Intellisense, you don't even have the argument of having to type them in. And yes, there are still users who use Notepad to program web applications and other tools that don't support Intellisense. But again, this is not the 80-20 rule, correct? Let's optimize for the 80% of customers who do use Intellisense-based editors. So we don't use abbreviations, we don't use underscores, acronyms, and so on and so on. This is all kind of well described in the naming guidelines. Oh, and the last one is very interesting. So I was talking about this when users approach a framework, they try to find the type that they should use to implement the basic scenario. And they often go to the most appealing name, correct? So you can imagine if they try to read from a file, they will go and try to find a type that is called file. In the I/O APIs, file I/O APIs, file is the most appealing name. It's also the one that we did use. I will show some examples for the common scenarios. But sometimes the best name ends up being used for a type that is actually not the one that we want people to implement. So an example would be, I worked with the printing, the team who was developing printing APIs in WinFX. And the main component that does printing in the operating system is actually not the printer. Correct? Because the computer has no concept of a printer. Printer is an external device. So you are talking with your APIs to the computer, and computer has a concept of a print queue. Correct? So the main API in their printing namespace was called print queue. That's how you communicate with printers. And of course, users will not be drawn to this API, correct? They will be looking for something that is called printer. And printer happened to be some API that does configuration for printers, and that's not the one that you would use for printing. And that caused a lot of kind of usability problems. So it's very important to kind of stop for a moment and think, do we want to be 100% correct in terms of, this is not the printer, this is a print queue, or we want to optimize for the user who just finds the API, prints, and doesn't bother trying to understand how the operating system works. And then for those who need to, they have time to read our documentation and blogs and books and kind of understand all the details of the system. So the previous slide was kind of talking about having a very explicit names, and this is an illustration from the serial port APIs, another API that is relatively complicated. It seems simple, but there are handshakes, protocols, and so on and so on. But as you can see, the BCL team did pretty good job, correct? You would probably you would open the namespace and immediately go to the serial port class. And this is the Swiss Army knife, correct? It gives you access to kind of the 80% scenarios through very small set of APIs. So another very powerful tool for kind of improving simplicity in the framework is wise use of exceptions. Exceptions in the past we used error codes, correct? And we had to document what error codes mean, and sometimes error codes were not documented properly. Sometimes it was difficult for developers to find the mapping. Sometimes error code could not carry as much information as exceptions can. So error code can only map from this is the error condition, go to the documentation, we will give you a very general description of the problem. Versus exceptions, of course, can carry a lot of information that can be used by developers to kind of diagnose a problem. So that's kind of one big benefit. But a more interesting thing is that historically we try to avoid exceptions, correct? So we try to design APIs that don't throw exceptions. And that can be done through some of API idioms like let's force the user to specify every single setting in the constructor, correct? They construct the object, and now it's in a well-known state, and they cannot get the object to a state that is slightly inconsistent. And we found that often it's better to kind of let the object get into an inconsistent state and then throw an exception explaining the state. And we use it as a communication tool of how the API works, correct? So if you design an API and it doesn't throw exceptions, it may be actually hiding kind of interesting information that we would like to communicate to users, versus exceptions make it a bit more flexible for you to design the other APIs, not worry about kind of getting the object into inconsistent state, and then communicate the mistakes and teach people about the APIs through the exception messages and so on and so on. And I will show an example probably a bit later. So here's one example. So event log is an API that allows you to write to the event log. And before you can write to the event log, you need to register a source, and you basically have to have a source. Source is usually the application that generated the event entry. So if you just instantiate the event log in the framework and try to write to it, you will get an exception. And an exception is very explanatory. Says source property was not set before writing to the event log. It could be even probably more explanatory, say something like, set the property, the source property before writing to the log. But this one is pretty good. So what just happened here? The user tried to implement the scenario the way they thought about the scenario. This was their mental model, correct? I instantiate an event log, and then maybe I specify there's a property on a log, which log, like application security and so on. I specify which log, and then I just write, correct? This is the mental model that you would expect from a user who doesn't understand all the details of the technology. So they did that, they got an exception, and the exception has taught them about the concept of a source. Now, if we contrast it with the scenario where we would force people to pass the source name to the constructor, many people get discouraged and surprised, correct? They open the bracket for the constructor, and Intellisense tells them, you have to pass a string that is the source of the log. And what happens is they go back to the documentation and they have to read about the sources. They're kind of completely set off the track from the kind of developing their prototype or a simple application. And we observe that sometimes exception is actually a very natural way for them to kind of progressively learn about the API, as opposed to learning ahead of time. So I talked about simplicity, and I have a small quiz. I'll let you read that, and if anybody wants to volunteer. So the quiz is meant to kind of reinforce the concept of giving up some features for simplicity, correct? And arguably, the things in Group B they provide more functionality, but they are a bit more complex, and therefore probably the things in Group A are a bit more successful. So I was talking about paper clips. And the many people attribute the success of the iPod to simplicity, and same with RSS. I've recently talked with the web services team who was talking about kind of how RSS became or is becoming the kind of standard for web services and communication between computers. So just an interesting observation and illustration. So let's move to the kind of second principle of understanding your users very well. And I mentioned designing for the engineer next door, and the way many APIs designers approach the API by kind of not recognizing that their users will never be experts in the technologies that they produce. And this kind of slide deck is meant to say that you should probably start by assuming that your users are aliens. They know nothing about your space, correct? If you want the very broadest reach of your APIs, then that's basically, I think, the best assumption to make. And then what do you do, correct? So once you make the assumption, my users are aliens, I need to understand them. I need to understand their goals. They may be very different from mine. And again, I will let you read this slide, but this is we sometimes design APIs and we say, well, okay, this part is easy. Here the user will struggle just a bit, and that's fine. We will provide great documentation, and maybe we will write a blog or not. And Rico was calling, so this is the pit of despair, correct? The user constantly has to read something, know somebody at Microsoft, in a lot of cases, to be able to use an API. So he talked about this concept of a pit of success, correct? Why don't we when the user walks around the API surface and tries to implement the scenarios, why don't we let them fall into the pit of success instead of kind of struggling and falling into the pit of despair? And that may be a bit. I was just talking about throwing exceptions, correct? Letting users on the path of doing the wrong thing. But this, I think, is a bit more high level, correct? What matters is the end result. The user got the exception, read the exception, learned about the API. They did not have to read documentation. They did not have to understand what sources are. So now, some introduction to the story that will follow. When we designed the file I/O APIs in the .NET Framework 1.0, we did not test usability of these APIs before we released the framework. Just didn't have time, and we kind of revised the API several times. Finally, we arrived at something that we thought, this is it. And it was kind of too late to test it. Usability studies take a long time. So we released the API, and then we started to receive feedback from users saying that they are very difficult to use. And we kind of, being experts on the technology, we did not understand why. So we said, hey, let's do kind of retroactive usability study, correct? Let's not worry that we cannot fix much after we already shipped it. Let's do a study and understand what the problem is. So we did a study, and actually 8 out of 8 usability subjects were not able to either read or write from a file within the time. So, and the time was like an hour or something, correct? So you have 8 people, kind of average, Microsoft developer, correct? Not Microsoft, kind of people working at Microsoft, but our customers, correct? 8 customers were not able to read or write. I mean, the extreme of failure, correct? In one of the most important APIs. And this sample kind of illustrates why. So there's this user, and the user thinks, okay, I need to read from file. Let's see what I do. So they go to the namespaces, and they discover that there's system I/O namespace. And, things are looking good. So they import the namespace, and then they start looking for the type that will let them read from a file. and they discovered this type called file. And they say, wow, great. File is something that I need. So they instantiate the file, and they run into the first roadblock, correct? So file, and if you look at the message, the error message that the compiler gives you, it doesn't say that the file is a static class with just static members, correct? It just tells you that the constructor is protected. I will be talking more about the ecosystem, how other things besides APIs influence how people can successfully use APIs. But this is one example, correct? The error message doesn't tell you what's going on. In reality, the class is a static class. So the user is like, OK, I'm not sure I will be able to do that. Let's back up. So they back up, and they discover that there's a static method on file, and they can open the file using this method. And they're like, OK, I'm golden now, correct? So they select open, actually read, and they pass a file name, and they see that it returns file stream. So this is another roadblock for some users, correct? Users would like to, I'm dealing with files. I don't actually understand the concept of a stream. We do have many users like that, correct? They are not concerned with kind of the architecture and abstractions and whatnot. They just want to use APIs. But hey, file stream, whatever, they probably know how to design APIs. So I will use file stream. So they create a local variable of type file stream and assign the file stream to it. And again, kind of the failure of the ecosystem, correct? Our documentation in Framework V1 was starting with a note about asynchronous APIs and so on and so on. Because that was the most important thing for people who designed the API, correct? It was not that file stream can be used to access the file system. It was how the asynchronous, how threads work in this API, correct? That's the important part. The rest is not important. We know that, of course. So the user was staring at this documentation, and many usability subjects that I was talking about, they were staring at this message and saying, I don't think this is for me. I don't care about asynchronous or synchronous operations. I will try to find some other type to do this thing, correct? That was, some people ran into this case. But let's say this user said, I will try to use it. So they try to use file stream, and they find the method read, and then they discover that the method read actually takes input parameter byte array, correct? And is that what a developer who's not concerned with performance and how it's built would expect the API to look? Like, I'm supposed to pass an array. I want to get array of bytes at least, and maybe even strings at best. So the user is completely frustrated at this point. Honestly, if I saw this API for the first time, I would not know what to do. And then offsets and counts, I don't know what they are for. So they completely back up, correct? Not for me. So miraculously, somehow they find the API that actually is the API in the framework to read lines from a file, or it was in version 1.0, and it was called Stream Reader. And I don't think this is the best name for kind of the most appealing name I was talking about, correct? But this was the type to use in first version. So the user finally finds this type, instantiates it, actually calls the method open text, finds the stream reader, tries to read lines, and then they run into another roadblock. So I will be talking about the concept of trying to be simple from what people know, correct, and only being different if there's a very strong reason to be different. And this is a kind of manifestation of the problem, which is many of these users used VB6 in the past. And in VB6, there was this file stream object component, and it had a property called end of file that would let them iterate over a file and then discover when the iterator reached end of file. And And of course, they would try to do the same exact thing in the .NET APIs. And could it find it in .NET APIs, the reader actually returns null when it reaches the end of the file. And it's just such a simple thing. There's no reason to be different here. We could have added this property. And in fact, I think we added it in .NET Framework 2.0. But in 1, we didn't have it. And that was, for many people, in an hour, 5 roadblocks. That's plenty, correct? So they would like, dead end, I'm not using this API. I'm not using .NET Framework. Some of them would search and find a sample, correct? So that was our kind of way out. But the problem is, as my boss calls it, it's a lipstick on the pig, correct? Code samples and so on, and calling your friend and whatnot, it's the lipstick on the pig, especially for such a very core APIs as File.io. So how do we let developers fall into the pit of success for File.io APIs? In .NET Framework 2.0, we spent months and months and months trying to design the silver bullet. And as I said, it's very difficult to fix APIs after they ship. Like the file name is already taken, and the APIs are taken, and the file type is doing something completely different than we would like it to do, and so on and so on. But I think we found a pretty good solution. Maybe kind of obvious after the fact, but the 80% scenario is users want to read all lines from a file. And in 99% of the scenarios, the file is actually not that big, and there are no performance problems with just loading everything into memory. Correct? If you run into the case where it's not performant, we still provide the APIs to do it the old way, correct? You can read line by line. You can be asynchronous, and you can cancel the operations and whatnot. We give you all the power that the operating system gives you. But for not even 80, for 99% of the users, this is the API to use, and it's so simple. So the user just selects read all lines, passes the file name. They can pass optionally some other parameters to open it with sharing and whatnot. And then they get an array of strings, and they seem to be happy. So, so what do users want from our APIs? One of the kind of most requested features, not features in the sense of kind of allowing people to do a specific thing, but kind of cross-cutting features that span all APIs. They want to be able to experiment with the APIs. They want to be able to learn the APIs by just trying them, correct? Many people don't even know whether they want this API or not, correct? They read somewhere on the net that somebody provided APIs to program their Lego robots, correct? And it's not like their boss told them, hey, you have to implement this scenario, otherwise you're not going to get paid. They are probably hobbyists or whatnot. If they cannot experiment with the APIs, if we tell them, hey, here's 150-page book, and you need to read it first before you can play with it, they will not use it. So one of the kind of, as I said, very requested feature is provide APIs that I can just play with. And I was talking about the operators new, correct? The number of invocations of the operator new in the code samples of mainline scenarios is kind of reversely proportional to the number of people who will be successfully using the API by just experimenting with it. Strong typing is another one. So many of our APIs either return, the worst case is they return objects, correct? And they require dynamic cast to do something interesting. But that's kind of on the extreme. There are some APIs that, for example, require people to pass strings in. But they cannot pass any string, correct? It has to be a string of a very specific format. You can probably imagine XPath, correct? XPath has this problem. It's a very powerful API, The problem is you need to know the XPath syntax. And the user is like, I already had to learn .NET and C#, and now I have to learn, XAML. And in addition, I have to learn this XPath syntax, correct? How many things do I have to learn before I can start using your technology? So I don't know how many of you have seen Xlink. Xlink solves the problem, correct? It's equally powerful to XPath. But in addition, you don't need to know the XPath syntax. It was built into the language. So that's that's what I would call strong typing in a kind of broader sense, not returning objects and asking people to do casts. And another thing is domain correspondence. So this is what I was talking previously about the print queue and printer, correct? Users are not able to experiment with APIs unless the APIs match their kind of mental model of how the world works. Users don't understand how the operating system is built. They don't care. What they care about is, here's the first step in my scenario. If I want to print to a printer, I first need to find something that represents a printer and then call a method print. And they will try to execute on that. If they run into roadblocks, they will perceive the API as difficult to experiment with and have to read documentation. So this slide shows something that we call the create set call pattern. And the pattern basically says that APIs should allow to instantiate an object using a very simple, if not default constructor, set properties to kind of configure exactly what I want this object to do, and then call very simple methods. And that's to, you can contrast it with APIs that would, for example, either force people to pass many parameters to configure the object, or maybe pass many parameters to the methods to control what the method would do. And many of our users expect this pattern to be implemented in the mainline scenario APIs. The reason for it is that we actually taught them to expect this pattern through the way kind of our tools spit code when they use designers, graphical designers. So when you use WinForms Designer and you drag, let's say, a timer component on a message or on a form, what happens is actually in your code we create a line of code saying timer, timer 1 equals new timer. Correct? That's all we do when you drag and drop. That's all. Then the users are expected to go to the property grid and set properties. So they set a property like interval and whether they want auto reset event and so on and so on. And those basically generate code that set properties. And then we tell them, okay, now go to a method where you're writing code and start writing code, and the object is set up for you. It has all properties set up. You can just start using it. And initially, this pattern was applicable mostly to graphical elements, like edit boxes, add buttons, and whatnot. But with Visual Studio 7, we actually have many non-visual components. I mean, like, really almost everything in the operating system, like performance counters, message queues, Active Directory access components, everything can be dragged and dropped on a form, and it generates code that looks like the following. And what happened is, now users expect all components to support this pattern, no matter if they are components that you can drop on a form and use and configure using the property grid or not. And this is also the reason I was showing this example of a user finding the file type and trying to first instantiate it, and it didn't have a constructor, it was a static class. That was basically, the reason is the user was used to this pattern. And now we've done some usability studies. Most of our usability studies are based on, or rather are focused on a specific API or a specific product, correct? Like we test the code editor and refactoring tools and so on and so on. We did one usability study that was more general study. So we studied what does it mean for an API to be designed as a create, set, call API versus some other approaches, like I was talking about, forcing users to pass more parameters to a constructor. And kind of API, people who are very advanced developers and who work on our team would say, this is not the best way to design. Let's forget about the designers. Let's forget about what users expect. This is in isolation from kind of what users expect. This is not the best way to design APIs. But then we did this study, and it turns out that many, even very advanced developers prefer that. Correct? They like the default constructor. They say putting the object into a known state by forcing me to pass constructors actually would be very helpful if it could accomplish the goal in practice. But in practice, when I receive an object from somebody, I don't trust it. I still want to check whether the path was set, whether it's in the state that I'm expecting. I'm not just kind of saying, okay, it doesn't have default constructors, I'm going to just use this object that somebody else passes it. So we tested the pattern with like C++, very advanced C++ developers, and they said, we actually like it, and we don't know what all the fuss is about. And maybe more studies should follow, but we definitely didn't find evidence showing that this is something kind of inferior. So we advise for the very common line scenario APIs to actually use it. So now, this seems like a bread and butter guideline, correct? You're designing a framework for 10 million customers. Designing for a very broad range of developers is a smart thing, but as with the simplicity, we found that it's important to make it very explicit, correct? When you design APIs for the .NET framework or for very large set of users, there will be a lot of diversity. The users will want to do many different things with the APIs, and will want, they have different styles of learning, they have different expectations, they are rewarded by different things, correct? We know we have users who, for whom kind of creating something quickly that works is very rewarding. We have users who want to understand all technologies that we build. There are users who seek rewards in kind of being proud of something that they created and survives for many years. So understanding all these users is important and plays into the kind of API design approaches that we use. And we have a website describing personas, so we call these kind of user groups personas. And we talk about the opportunistic developers who basically want to sit in front of the computer and start coding and discover problems and then improve the application kind of on the fly. And recently, there's more and more interest in dynamic languages, correct? You're probably aware of. And I think it's very related. People realize that type safety is important. And it's very useful, but it may be not that important or not that useful when I'm prototyping, correct? I want to create something very quickly and make it work. If I get an exception, I just quickly fix the problem. But the moment I change my mind, I didn't want to use a string, I now want to use just any object, I don't have to rewrite my whole API surface, correct? That's what dynamic languages give you, one of the things. So you have to understand these developers and these scenarios when designing APIs. There are the other, kind of on the other end of the spectrum, there are those systematic developers, correct? So systematic developers, when we do usability tests with such developers, it's kind of interesting to observe what kind of challenge they pose for the usability engineers. So the opportunistic developer would sit on front of the machine and start coding and talk, and researchers want to hear from the users their observations. So the user sits and says, "Oh, I'm trying to find the file component, and I'm now having problems finding it. I found it, but it doesn't have a constructor," and so on and so on. So they are easy usability study subjects. And then the systematic developer, we would get them into the lab, and they would have an hour to read from a file. They would spend 50 minutes reading MSDN, correct? They want to learn every single thing in the file I/O APIs before they proceed to writing a first line of code. That's a funny anecdote, but it shows kind of the difference in approach between different developers. So, knowing your users, there is a limit to it, correct? You can learn a lot about the users. A really good way to kind of discover the remaining problems, and even to kind of learn about your users even more, is to actually do usability studies. So we have, in the developer division, we have usability engineers who specialize in testing APIs. Majority of the usability engineers at the company specialize in kind of testing GUI components, but we do have API usability engineers. And those are very formal, correct? They are in kind of controlled environment. You have to design the study ahead of time, and so on and so on. But it's very useful to do a very informal usability study. And that goes back again to the designing for users who are not experts. I think the single main component of a usability study is get somebody who's not an expert in the thing that you're designing, correct? And just give them the API and ask for comments. You can discover a lot of things that then are discovered in formal usability studies. And we do it all the time through we organize application writing sessions where we just invite people from across the company and we say, "Hey, we created this new API called WPF. Why don't you come and try to create an application? And if you're working on media, create a WPF application that does something with media. If you do printing, design a printing dialog or something." And this is a very powerful way to kind of get closer to the user. So now the third kind of principle of good API design is designing for the ecosystem. So long time ago, development was mostly about maybe even learning the language, correct? People would associate themselves as Fortran developers or Lisp developers, and the framework was small and kind of maybe not significant. And then there was this stage of, okay, frameworks are becoming larger and larger. We expect you to know a language and a framework. So people started to talk about themselves as Win32 developers or MFC developers. And I think now we are at this stage where when people say, "I am a .NET framework developer," they don't even mean they are developers of the APIs. They mean the whole ecosystem. So that includes things like MSDN, correct? I know how to navigate around MSDN. I'm a .NET Framework Microsoft developer. I know how to use Visual Studio debuggers. I know how the refactoring features Intellisense works. I know different parts of the framework, even if they don't directly correspond to the things that I'm working on. I'm a .NET Framework developer means very broad set of expertise. So when you design your APIs, you need to think about these other elements, correct? They play a larger and larger part in the overall experience that the users will have. when implementing API scenarios related to your APIs. So what are the kind of elements? I'm going to go through some of the elements of the ecosystem, illustrate how they influence the design of our APIs. So first, and probably the most powerful, is the Intellisense. I'm going to talk about how Intellisense often makes us create APIs that, again, in isolation we would consider worse, but within the ecosystem we think this is the optimal solution. And many people say, why would I design my APIs for an Intellisense system that will change, possibly will change very soon? I'm a framework designer. It's such a, important activity. I don't want to deal with Intellisense tools, MSDN, and whatnot. But I think this is a very short-sighted view, and I hope to illustrate with this one. So I created a component called myFile component. It's not a real component, doesn't exist in the framework, just for illustration, and it has two methods, append and override. So it appends to a file or overrides contents of a file. So now the user tries to use the component, they instantiate the component, and they bring up the Intellisense dropdown, and the Intellisense dropdown shows the members in alphabetical order, correct? So append is at the top, and override is second to last. Now, for a dialog that is 6 element long, that may not be such a big problem, but we do have many APIs that have, or many types that have hundreds of members. So you can imagine if you have 100 members, it's really difficult to browse the Intellisense list. And what happens is often users scroll the list, they find the first member that seems like it will work for me, and they choose it, and then if this is not what they want, they struggle, correct? To get it back, for the Intellisense to show the window again, you have to backtrack, you have to type the dot again, then you have to find the element that you just typed to keep scrolling down and finding another one. So it's very difficult when you kind of make a mistake to recover from mistakes. So let's see how we kind of can improve the situation so there's less chance of a user choosing, append when they actually want it to override or vice versa. And it's just to force the order in Intellisense by kind of clever or ugly naming, whatever your opinion on this subject is.
So are you seriously advocating doing this as opposed to just fixing Intellisense?
Yes. So maybe I should repeat the question. The question is, are we seriously advocating changing how we name APIs versus fixing Intellisense, correct? So I participated in at least 3 exercises intended to improve how Intellisense works. And it's one of those things, those hard design problems, where you fix one problem, you introduce 20 others. Honestly, Intellisense that is based on the alphabetical order of identifier is the best we know. And it's not like we just invented it one day and didn't spend a lot of time trying to improve it. There were many ideas of, can we make some elements, in bold font to kind of indicate these are the important ones? Can we sort them differently? Can we have different tabs, one for the commonly used APIs and one for the advanced APIs? We tried it all. It doesn't work. You run into kind of the classical problems of users, always switching to advanced because the first time they didn't find the API that they wanted in the kind of easy APIs, they switched to advanced, never switched back. Those are common problems that we know from graphical user APIs, graphical user interface design and so on and so on. It's a very difficult problem. So yes, we finally at the stage where we admit we are not able to improve Intellisense. This is what it's going to be. Correct? Now you can design your framework to play worse with the system that we have or better with the system that we have. And of course, you cannot take it, we are not advocating to take it to the extreme, correct? You're not going to call your names, your APIs with names that have nothing to do with what the API does, just to sort it alphabetically, correct? We are not advocating to start prefixing everything with some prefixes so it sorts in the way that we want it to sort. But it's something to think about. So this example is not do that, correct? Always do that. It's like, think about this. It's a very powerful technique, and it's not going to make you as the API designer kind of, sacrifice some, principles. Don't worry about that too much. So, a simple technique of prefixing, or in other way, kind of choosing names based on how they will ultimately sort in Intellisense is a very powerful technique.
What about if they're having, just one write method that takes another parameter, enumeration, append or overwrite?
Yes, so the question was, would it be better if it was just one method with a parameter to either override or append? So I have to admit that this is an example intended to illustrate kind of a principle. There are many cases where you cannot, or it would be it would result in an API that is not easy to use. If you had, you could say, oh, let's have one method, let's have method A, and everything is controlled with parameters. That's one extreme. Another one is often the Intellisense dropdown. As I said, this is the very important moment where the user has to commit to a method. And if this is not the right one, they have to backtrack. So we often kind of want to communicate as much information as possible in this dropdown. So another part of the ecosystems that our developers got used to and love is the integrated debuggers, correct? You probably remember programming from 10, 15 years ago. It was such a pain. Now, the pain kind of doesn't exist for majority of developers, correct? You can still run into cases where our default debuggers are problematic, but for majority of developers, this is it. They love it, and we are probably, we will be doing some changes, but it's a pretty stable technology. So now, this is an example illustrating a very common problem, which is you designed a complicated data structure, correct? So internally, it may be complicated, even more complicated than a linked list. Let's say, hash tables, correct? They are very complicated internally, but this is not what the user cares about, correct? So if you inspect this linked list in the debugger, it will show you all the internal implementation details, correct? So it has nodes, and nodes have pointers to the next node, and each node has the data component, and so on and so on. Well, this list has only 2 elements, and it already looks very messy in the debugger display window. You can imagine that a list with 1,000 elements would be impossible to kind of inspect in this debugger, correct? You would have to expand 1,000 times to get what is my 1,000th element. So again, the mental model of a list, or the thing that the 80% scenario user cares about, is what are the elements in the list. And Visual Studio 2003 debuggers were showing basically exactly this view. Now, what we did in Visual Studio 2005 is we added this concept of debugger viewers. So debugger viewer is basically a proxy for a complicated data structure that the debugger will show instead of the data structure. And each data structure has an attribute, and the attribute says, here's a type that basically represents my viewer. So instead of showing me all my internals, go and show the proxy. When the proxy is instantiated, it gets the actual data structure as a parameter to the constructor, so it knows what it's supposed to show. And developing the proxy is very simple, correct? So proxy is basically it can be any type, and the debugger just shows its properties. And if the property is a collection or an array or something, it just shows a list of the elements in the array. So the linked list debugger viewer would just walk the linked list and create an array with all the elements of the linked list. Correct? Very, very simple. But such a big improvement for kind of end users trying to just debug the linked list and see what the 1000th element of the linked list is.
Is that supported in C++ CLI?
Because it seems like it has C++ CLI has that problem. Still.
Interesting. So I talked with somebody about that. The question was, does it work for C++ CLI? And I don't remember now. But just, try hash table in Visual Studio in 2005.
Yeah, 2005 will give you
The complicated view. Okay, unfortunately, but
maybe some trick of how to check.
Okay, I honestly don't know, but email me. I can ask people. So, and of course, I was talking about making the 80% scenario simple and the 20% scenario possible. So there are users who want to understand performance problems with their hash table, correct? So they want to actually understand how did the hashing algorithm bucketize all the items in the hash table. So they don't want to see this view. They actually want to see the buckets. And we don't make it simple, but we make it possible. You just expand the raw view item in the list, and it will actually show you the exact same view that I was showing on the previous slide, all the guts of the data structure. Go ahead.
I was actually going to save this question until later, but since you have several examples that show this, I'll say it now. How are we supposed to know these attributes? Like you showed 2 slides ago, this debugger proxy thing.
Yep.
In terms of building frameworks, how do you tell the user that there's this thing that you hit a square bracket and then you have a whole bunch of attributes in front of a function or a class?
So the question was, how do we communicate to users that they have to apply this attribute? Well, so users don't have to apply this attribute. It's only people.
Yes, but there are cases where, like in web services, there's a bunch of attributes you can apply before your web services.
I see. Okay. So the question is a bit kind of more general than how do you apply these specific debugger attributes. And you're asking kind of how do we communicate to users that they have to apply any attributes in general when they program the framework. Yes, and so attributes are actually very problematic from kind of usability perspective. Majority of our users, and again, maybe that's learned, they want to basically code. Anything that goes kind of outside of the coding window breaks their kind of line of thought, correct? They want to just instantiate types and set properties and call methods. That's all they want to do. The moment you ask them, oh, you have to, generate, create an XML file that specifies manifest. Okay, they bump into, like I was showing the pictures, into a tree, correct? That's some new technology that they have to learn how to do. The same is maybe not as severe because, again, we evangelize attributes as the way to create metadata in .NET. But still, it is a big problem. It breaks their line of thought. It's something that Intellisense is not as great for as just selecting methods from a drop-down list. So attributes are problematic, and we try to use attributes for things that are optional. So that goes back to the idea of you want users to be able to quickly start, have low barrier to entry, quickly start with an API, to a point where the API does something, correct? It may not be the perfect way to implement the scenario, but it does something. It's pretty close. As long as you can get them to this point, then they can read. They can find, some coworker tells them, hey, if you apply this attribute, you're gonna make it faster, correct? If you apply this attribute, you're gonna make it more, serializable, and you will be able to serialize this data structure. And we kind of try to keep attributes for these kind of optional things that improve a design that is purely done through coding. So CLS compliance, how many people know what CLS compliance is? Okay, so let me explain. CLS is Common Language Specification, and it's basically an agreement between compiler vendors and .NET framework creators as to what subset of the whole CLI, our type system in the runtime, frameworks should expose and languages must be able to consume. So basically, if you design your framework and you stay within the subset of specified by the CLS, you can be sure that all languages that are CLS compliant will be able to consume your framework. All languages written for the .NET framework. So this is one of the, and our languages on the .NET framework platform are one of the big contributors to the large ecosystem, correct? .NET framework is, I think, the first frameworks that enabled this kind of multitude of languages working in the same, again, ecosystem of tools, frameworks, debuggers, and so on and so on. It's a very powerful feature of the overall framework. So now, at the same time, it's one of the easiest to get incorporated with your APIs. It's just a matter of applying the CLS compliant attribute. You apply this attribute to your libraries, and I know C# compiler and VB compiler. I'm not, again, sure about C++ compiler. Will actually generate warnings for all the APIs that go outside of the set of CLS compliant type system features. So it's better to probably illustrate it with a sample. So unsigned integers are not in the CLS compliant subset, correct? So our type system, the CLR type system, allows unsigned integers. And in fact, we have types in the framework that represent unsigned integers. But we decided that unsigned integers will not be in the CLS subset. Therefore, not every single language has to be able to deal with unsigned integers. And if you design your APIs, you cannot use unsigned integers because some languages will not be able to use them. So here is a simple illustration. I applied the attribute to my assembly. I created a type called customer, and it has a property, and the property is an unsigned integer. And you get a clear warning from the C# compiler telling you that it's not CLS compliant. So now you can decide if you want your library to be only consumable by C# and some other languages that support unsigned integers. You can go ahead and ignore the warning. But if you want to integrate with the full ecosystem of other languages on the .NET platform, you better change it to something else, not use unsigned integers. Maybe use a long and only use the positive part. So another set of guidelines to kind of enable integration with the ecosystem is to enable integration with other parts of the framework. And this is a very common design mistake where a team would design APIs and think that what we are designing, this is it. This is the end of the world. Like, solves all the problems. This is our APIs. People don't need to use anything else, correct? And it's more common in like those big teams. So I was talking with some people who were saying, this is how we're gonna do it in our part of the framework, because people writing, let's say, Avalon applications, this is how they expect the things to work. And and my next question would be, but who's gonna be writing Avalon applications? And initially, they seem to be thinking this is an attack on our technology, and in reality, I'm just asking, there are no Avalon applications. There are applications that do data entry, do music, media, and so on and so on. They happen to be using Avalon as the GUI framework, but this is not all you can do. If you created an application that just used Avalon, it would be just showing pixels on the screen, correct? That's not it. People have to use performance counters, people have to use networking stack, people have to use XML and whatnot in real world applications. And so you have to think about kind of integrating with these other technologies. And for something like GUI framework, it means being able to, for example, accept collections that already exist in the framework as data binding sources, correct? This is an example of integration of GUI frameworks with the rest of the platform. And maybe not even from collections. You want to, let's say, read a set of peers from the peer-to-peer APIs, correct? And you want to be able to data bind this collection of peers to a control in the GUI framework. So kind of using common abstractions is a kind of one of the most important things to remember when you try to integrate your framework with frameworks that already exist or components that already exist in the .NET framework. And there are some important ones, like using the least derived type as input parameter, correct? So if you use an object as a parameter, and your method inside the body of the method just prints the toString value returned by the object, object is fine. It does the work that you want to do, correct? If the method is just, let's say, log object name, you can take an object, call toString, and log the name. You don't need any kind of more strongly typed APIs. When you, for example, implement a simple data structures, it's very important to implement interfaces like IEquatable. This interface is something that allows data structures to be used as keys to hash table, and so on and so on. So we have many of these guidelines in the design guidelines book. I'm not going to kind of walk all of them, but kind of be familiar with the abstractions that we have in the framework and use them properly, even if you design something that is only related to the APIs. Well, so if you implement an interface and you use it as a constraint of a generic parameter to a larger data structure, actually it doesn't box. So if you take IEquatable as a parameter and you implement IEquatable on integer, let's say, yes, it will box the integer, and that's not going to be performant, correct? But we use many of these interfaces as constraints on type parameters. So let's say list of T or dictionary, correct? Dictionary KV would constrain K to IEquatable of T. At that point, compilers enforce that the constraint is met. And inside the implementation of methods that operate on keys, we actually don't box. So that's how we use interfaces, abstraction interfaces on value types. Interesting. So this is just an illustration of the concept of kind of using least derived types as input parameters. So I created a class customers, and it has a method add names. And the method takes a string array. So now, if I happen to have my input arguments in a string array, everything works fine. I can call customers, add names, open bracket names. This is the second to last line, and it works fine because names is a string array. But if I have a list of strings, this is not going to work, correct? So the designer of the add names APIs didn't think that it's worth integrating with the generic collections. So now this is a trivial fix, but people don't think about this very often, is basically inside my add names method, I just iterate the collection and put the items from the parameter into my internal customer structure. So taking IEnumerable of string is good enough. It provides all the functionality I need and integrates better with other things that implement IEnumerable.
On that example, when should you use uppercase string versus lowercase string?
Yes, so the question is, when should I use uppercase string versus lowercase string? So first, they are completely equivalent, correct? The lowercase string is just an alias in C#. And some people thought, I talked with people who thought that string uppercase is a reference type and string lowercase is a value type, which again illustrates maybe we do have a problem. We should have just single name, correct? So people don't have to, more variation, you have people ask questions like, what is the difference and why do we have it? But then what is the recommendation? So first, we have many naming guidelines, but we stayed away from having guidelines for internal implementation. Like we wanted to get out of kind of always arguing preferences, personal preferences, and those are mainly that have no impact kind of on end customer. And that's what internal implementation guidelines basically are. So we said, for internal implementation guidelines, teams should agree on whatever they feel fits them. And our guidelines, naming guidelines, only talk about the things that, the artifacts that stay in the public API after you compile. And this is not one of those. And as I said, there are many philosophies. Some people say it's better to use the .NET framework names, which is the uppercase, because it's uniform. No matter what language, it's the same. Other people say, oh, we have those aliases in languages for a reason. The .NET framework is supposed to be multi-language, which means definitely not forcing language designers to adopt more and more standards, but rather kind of enable integration through the least amount of kind of standardization that would accomplish the integration. So we talked about this as example, and now type name conflicts. So I kind of briefly touched on that, but this is also another thing that kind of inhibits integration of different parts of the framework if not done right. So basically, do not name your types with very generic names unless your thing is actually a very generic thing, correct? So when we do API reviews and somebody says, I'm going to have this type and I'm going to call it a message, I say, fine, you can do it, but if anybody in the .NET framework says, I have a concept of message, and then I will come to you and I will say you have to support this person, correct? Like you will have to support their scenarios because you took the name message, you claimed I'm going to be this generic thing, message for everybody, so you have to support the wildest scenarios. If you don't want to do it, you can scope your name to saying something like my team message, correct? And I'm fine at this point. So this is a bit of an exaggeration. We use generic type names in the framework from time to time. And we often laugh at the reviews because I say, okay, you own the name item, correct? You're going to be like when we were doing the WinFS APIs, correct? So they had the name item, and they had an API called item. And we do have APIs called message. We don't have API called log. I don't think we have node. We probably don't have element. We have XML element and X element. But in general, we try to avoid them. We only use them if it's truly very generic type. And people say, things like we have namespaces and whatnot. But here's the problem of kind of using namespaces to disambiguate types. So let's say there are two companies or you can say those are two teams in the .NET Framework team, and they are doing technologies related to logging, but they are not exactly the same. One team is working on transactions, and they need logging because transactions do a lot of logging. And the other team is working on diagnostics, and they also do logging, correct? And they created this type called log. And now the user wants to use the type, and of course, if they type something, import both of these namespaces and type log that record transaction, they will get a ambiguity error. So the compiler will say, I don't know which one you want to use. Do you want to use the log from the event logging namespace or from the transactional namespace? And of course, the user can disambiguate. It's a bit long line of code, but maybe that's not too bad. But now the question is, why do we force users to do that, correct? Can we do something ourselves? So again, they don't have to even think. And you can easily do it through kind of, again, qualifying your type, saying, this is not this general log that will work for everybody for the next 20 years. This is a log that is specifically for transactions. This doesn't solve the problem completely, correct? Next time we do another transactions technology, we're going to run into this problem again. But it definitely mitigates the problem. We've been using the technique of kind of, if it's a single word, it raises a red flag, and we say, hey, is it really just a single word? If it's two words, the probability of clashing in the future is minimized enough that we didn't run into major problems. I think it's a good rule of thumb to kind of, two words makes it relatively safe. Go ahead, this question.
So I see this is kind of name clashing occur a lot between WinForms and WPF.
Yes.
Was this just because WinForms took a lot of names and you had no choice? Or?
Yeah, so the question was, there's a lot of name clashing between WinForms and WPF. And you can read more on this name clashing in the design guidelines, and it's described in a bit more details. So the guidelines are not as strict as don't have name clashes, period. They kind of give a bit more flexibility for things that you expect to never or almost never to be used in the same file, correct? So the biggest problem is if you use those two namespaces in the same file and you import them. That's very rare between WinForms and WPF. We do support scenarios of using WinForms controls in WPF controls in WinForms and so on. But they don't result in clashes. They are usually not the same file where you have to import both. Having said that the name clashes in your source code is not the only problem with ambiguous names. So there are some other problems that for example, searching documentation for these APIs, correct? Like, how many of you already run into the situation of, I'm trying to search something for the .NET Framework documentation, and I get documentation for the Compact framework, correct? Or some related framework that happens to use the same names. This within a single framework, and conflicting names, that is even bigger problem, correct? Like I scope my documentation search engine to .NET Framework reference, and I type log, and I get potentially 25 different types, and maybe the one that I'm looking for is the last one. So that's kind of another problem to think about when you think you may have a bit too generic name. And it's kind of interesting that it works well if you're working on a technology that is a corner case technology, correct? Kind of like an advanced technology for some niche market. You want your names to be less ambiguous than if you're working on general purpose technology. And the reason is people will not be able to find your API. If you're working on niche technology and you named something message, nobody will be able to find you, correct? Because those more general purpose technologies that chose message as a type name, they will be at the top in search engines, correct? So it's kind of an interesting thing to think about when you design kind of niche APIs.
Can a compiler actually prevent people from using log message? So when you do a compile at the compile time, can a compiler actually warn you cannot use this keyword?
So the question was, could compiler warn API designers that they are using short single word names? Well, the thing is that compiler designers are very conservative. They don't want to put, so they want to have rules for warnings and especially errors that are kind of strict, set in stone rules. They don't want to have this fuzziness, like if it's one word, it's probably 50% chance that you're doing something wrong. If it's 2 words, it's 90%, correct? So I don't think that compilers are the best tools to do something like that. But for example, we have this tool called FXCAP. Maybe some of you have heard about that. It's basically a static analysis tool that loads an assembly and uses metadata readers to kind of analyze the API surface. And that would be a good candidate for a rule like that. And in fact, I talked with the FXCAP team to having something like that, even having an explicit database of all type names in the framework. And if you use a type name that already exists, warn you. So they are thinking how to implement it efficiently. There are, again, design challenges and trade-offs when designing FXCAP. It has to integrate well with the build systems, and the build systems integrate on different schedules, and how do you update the database, and so on, but they are thinking about this. So, again, during API reviews, I often joke with the teams that my job here is to make your feature worse so that the whole framework can be better. And it's a bit of a joke, but not fully. There is this, kind of, I don't think I can help people in designing their APIs kind of as an expert in the API surface, correct? Like I will never be able to design the workflow APIs better in isolation from the rest of the framework. So my job is often to kind of explain to the teams how their APIs will integrate with the rest and interact with the whole ecosystem. And that often means that you make your API worse so that the ecosystem is better. And this slide also shows this quote from our general manager when somebody in a ship room said, "But my feature would be worse." And he said, "Well, but we are not shipping just your feature." Correct? And that's something important to remember when you design either components for the framework or components that have to integrate with things that other people produce. So this is the start of the next principle. I wonder if we shouldn't do like a 15 minutes break. Would it be helpful, useful? All right? So let's do 15 minutes break and maybe meet 10 after. Thank you. Let's get back to the presentation. So now the next principle is the principle of kind of using the power of consistency. And the slide shows kind of steps that we all know how to use. We don't even look when we walk steps on the steps, correct? You just walk and your brain tells you the next one is that far from the previous one. And once I went to a amusement park, and they were illustrating this concept. They made steps that had different sizes. And it was impossible to walk on them, even if you looked where you, like, it's so ingrained in our brains that steps are the same size. You look at the steps and you know they are different size, and you have to basically like walk, thinking about every single move that you do. It's a very challenging task, and the steps were made from like rubber or something, because I bet people fall on it all the time. This is kind of the power of consistency. Our brains, we expect things to be consistent unless there is a very strong reason to be inconsistent. And when you design steps, there's really not that many reasons to be inconsistent, correct? So all steps are consistent. So let's kind of, we have, I have like a short illustration of the principle. So when you rent a car, correct, what do? You kind of adjust the seats, find your favorite radio, adjust mirrors, and so on and so on. And what do you do then? You take the kind of manual from the glove compartment, correct? And what do you kind of read? Like, oh, if I will be leaving the car, I need to kind of, press these things. This is how you lock them. You can unlock them by kind of pressing some other button on the side of the door usually. It kind of tells you everything, how you use the keys to open the car. And it tells you how to use the seat belts, correct? Like this one thing with the loop goes into the socket. And then to unlock the seat belt, you need to press red button that says press. We kind of all went through this exercise. Shows you how to use turning signals, like right is up and left is down. It explains it very well. But you don't do this, correct? That was a joke. And the reason you don't do it is that all cars work the same way, correct? And you probably have heard stories about like how companies try to redesign the steering wheel in a car, correct? So steering wheel is not the best way to design this thing to steer your car. It's like it was invented 100 years ago when there were different sets of constraints, how to design the whole steering system. Today, in isolation, again, the steering wheel is probably not the best design. They try to come up with something like that looks like a plane, and it was not successful, correct? And the reason is that it violates the principle of the power of consistency. Features can only be inconsistent from something that users are accustomed to if the value of the difference offsets the negatives. And that's very difficult to accomplish in majority of API improvements and in general in inventions, correct? So we often, so that's Anders Hellsberg. He always told us that whenever you add a new feature or you change something in an API, you get minus 1,000 points. Like right off the bat, minus 1,000 points. You come up with, to a spec review, you get minus 1,000. Now, you have to demonstrate that your feature, your improvement, your change offsets the negative to kind of get the spec review approved. And that's a very powerful kind of way to think about this problem. So yeah, that's the illustration of, I was talking about kind of steering wheels that look like a plane. That's a very small change, correct? But you can imagine the whole car would be redesigned. The panel would be, showing you everything that anybody would like to know about how the engine works and whatnot. That would not succeed. We all agree on that, correct? Yet, we design APIs often like the airplane panel, correct? Like every single bell and whistle. And it's all there in the face of the user, in the main namespace, in the main components and the types. And if you do that, the market potential, of course, will diminish. I mean, amazingly. You're going to get the cutting edge customers who are kind of seeking to learn new technologies as opposed to solving, common business problems. And I was showing paper clips, correct? So the gem paperclip, I think it was invented and patented like in 20s or something, 1920s. And you know that people are still filing patents for paper clips. Like every single year, there's a patent for new paper clips. Honestly, and I read a book on this whole thing, and I saw on every single page there's a patent, and it's goes from early 20s to I saw a patent from 1995 or something. And there are small improvements there and there. Well, yet the majority of the clips that are sold are the gem clip. And you probably know it has problems, correct? It tears paper. There are those sharp edges. If you put the paper clip too far on the paper and the paper stack is thick, it kind of expands the paper clip and the sharp edge goes into the paper. But that's not yet a problem till you want to take out the paper clip and you tear the papers, correct? And people try to solve this problem by changing the shape of the edges and whatnot. Doesn't work. Costs too much, introduces other problems and so on. It's difficult to put the clip on and whatnot. So we have a lot of consistency rules. In fact, the design guidelines kind of started as a book of consistency. Now the design guidelines talk about kind of higher level patterns and idioms and so on, but they started as a very simple consistency guidelines. The very basic ones are naming guidelines. And naming guidelines can be, part of the naming guidelines is the casing. So you can read details on this, but we have this, Pascal casing convention. Anders worked on Pascal, and he came up with this name, and he used this convention in Pascal. And then camel casing. We had screaming caps, but we then kind of banned the convention from the framework, and we are not using it anymore, so we don't have to have a name for it. But it was basically all uppercase with underscore, and we planned to use it for constant fields, but then didn't use it. So now Hungarian notation. So this goes from kind of just purely casing and kind of mechanics of naming to kind of how do you choose right names for elements in your APIs. And in Win32, Hungarian convention is very popular and very useful. As people started to introduce kind of more extensive frameworks and maybe object-oriented frameworks and tools with Intellisense and whatnot, and actually in Visual Studio you can kind of put your mouse on top of an identifier. It will actually tell you with a pop-up what the type of the identifier is. It seemed to us that Hungarian kind of lost a bit of a value, and kind of maybe the kind of value versus drawback ratio now seems to be that it doesn't add enough value for all the problems that it introduces. And it does introduce problems. It decreases readability. It often gets out of sync from what is actually happening, correct? So you start designing APIs and your type is
string and you prefix your name with str, then you change something, you forgot to change the name, or changing the name is actually breaking, so late in the product cycle you don't do it, and so on and so on. Many in Win32 APIs, many parameters were simple primitives, correct? So you can have a Hungarian notation for, a lot of primitives, but the moment you start thinking about having Hungarian notation for thousands of types in extensive frameworks, it becomes more and more difficult, correct? What do you call them? They are all prefixed with object. So like you end up with a framework where 99.9 of your parameters actually use Hungarian notation. The rest uses it, but they are prefixed with object. I mean, the value doesn't seem to be there, correct? So we basically decided not to use Hungarian. And initially it was quite controversial, but now I was getting a lot of questions initially about that. But now it seems to be kind of accepted, and I don't get these questions anymore that often. So we have guidelines that, go ahead.
Members and globals?
Globals, you mean like static?
M_G_.
Oh, I see. Yeah, so for internal members, we don't have guidelines for internal implementation. We kind of try to stay away from telling teams what to do that doesn't affect customers. So, internal variables don't show in the public API surface after you compile it. We left it up to the teams. So, yep, exactly. We started to, there's a book on the design guidelines as well. Internally we have this document. It's exactly the same thing, except it's my English, not edited English by editors of Edison Wesley. But we have this book, and at the end of the book we actually included kind of simple conventions, because people are asking us about implementation conventions all the time, correct? So we get like, you got these guidelines for public APIs. They are very useful for ending all the fights on our team. Why don't you give us internal implementation conventions so we can end these fights as well? And we tried to, for a very long time, stay away from it. Finally, we kind of caved in. We have guidelines, but they clearly say this is optional. In fact, we were thinking about saying it's optional, it's blah, you don't have to use it. Finally, I think I said that it's a convention that I use in the book, correct? Nothing else. And people still take it as a convention that they are supposed to be using, but it's honestly up to kind of the teams. So I was talking about the concept of simplifying APIs by kind of decreasing the number of types that people have in the pool of which they have to choose from, correct? So you can do it through namespace factoring. Like you put mainline scenario APIs in one namespace and the advanced APIs in another namespace. So the user who just starts to learn about this technology, they probably import system diagnostics, not system diagnostics.eventing. They have less types to kind of worry about whether this is the one that they want to use. Another very powerful technique is to name types properly, correct? So one way is to give the very appealing name to the type that you want people to use. Another one is to give a bad name, or maybe I shouldn't call it bad name, but a name that tells people this is not what you should use. And we do it through a set of conventions to identify types that what we call them supporting types. So in every single, when you design APIs, you will always have 10% of types that are the most important types in the namespace, correct? This is the serial port, this is the file stream, maybe stream reader, and so on. And then you will have a lot of types that, honestly, if you think about them, they should be considered like the plumbing, correct? People were complaining about COM having a lot of plumbing, and I have to worry about things that actually I don't care about. And .NET eliminated many of this. I would consider supporting types kind of like plumbing in the .NET world. So if you add an event on a type, the thing you care about is I have an event, correct? The type system and the way we design our patterns, API design patterns, kind of force you to add 2 more types to the namespace. So if you have an event, you have to add an event handler corresponding to this event, and you have to add event args, which is like a data structure that carries the data of the event. These are 2 types that users need them, but they don't need to worry and try to understand them when they kind of explore the namespace, correct? If they use the event ultimately, which probably is one of thousands of members in the namespace, they will have to learn about these 2 types. But when they explore the namespace, they should just ignore them. So we have conventions for types like that, for these supporting types. So we suffix them with like event args, correct? If you see something called blah, blah, blah event args, like don't spend time trying to understand what it is. When you get to using the event that uses the event args, you will get to learn this type. For now, just forget about that. So the same applies to like exceptions. Majority of the users don't need to understand the whole exception hierarchy. They only need to understand some exceptions when they actually get an exception, or in rare cases when they want to throw an exception that already exists in the framework. So again, this is just a part of a table. In the design guidelines, we have a full table of kind of supporting types and their suffixed conventions.
For events, do you have a convention for the event itself, like on progress or something for the actual event?
Yep. So the question is, do we have conventions for events? And yes, we do have conventions for naming events. We used to have a presentation that was basically, let's walk all the guidelines in the whole book, and it was extremely boring. So now kind of the presentation is more about these concepts and then points to some guidelines. Many of these things are elaborated in the design guidelines to quite a depth. Now the naming guidelines in particular, you asked about them for events. There are 2 classes of events in the framework. The events that are raised before a side effect actually happens, and after. So you would have an event that is raised before a window is closed, and when the user presses a button, the window is about to be closed, we raise an event. And then we have another event that is raised after the window is closed. So we prefix the first one with ing, window closing. And some of these events can be canceled. So inside the event, you can get the event args and tell it, I don't want you to actually close the window. And then we have a second group of events that are raised after, and they are called in the past tense, so like windows closed. So then constructors and properties. I kind of briefly talked about this create set call pattern, and this is a related set of guidelines, kind of consistency guidelines. People expect if you have a design where a constructor parameter actually initializes a property, which is, again, a kind of very useful idiom, correct? So I was talking about having default constructors. It's fine to have other constructor overloads that are helpers for people who want to set properties or configure. And if you do that, if you have those overloaded constructors and they initialize properties, the parameters to the constructors have to be called the same as the properties. And there shouldn't be any semantical differences. So there shouldn't be a difference between me passing a name of a log to the constructor versus setting the name of the property called machine name. Properties versus methods. This is another thing that it's a consistency guideline, and it's a consistency, again, kind of, we taught developers to expect this consistency. We could have chosen completely different approach, but now they expect us to follow the guidelines for all the components in the framework. So the main kind of difference between when we choose properties and methods are kind of expectation of the developer as to the performance of the operation. So they expect properties to be on the order of accessing a field. Right? It's a property. It's a color of a button. Why would you have to do a lot of work to get color of the button? So if we discover operations that are a bit more expensive to execute, or when they have like unexpected side effects, we usually make them methods. Now, don't take it too far. I ran into cases where, people had a type called customer, and it would have two properties that are actually backed by fields, let's say first and last name. But then they would make get full name a method because they have to concatenate two strings. And I think this is taking the kind of principle a bit too far, correct? From the customer's perspective, again, they are not so concerned with implementation details. They are, at some point, if we start accessing network from properties, they will have to be concerned at that point. But don't take it too far. Some kind of execution inside the property getter to produce the result is not too bad. Some of the let me look if I went through all of the conversions side effect. An interesting one is if a member returns an array, it should be a method, and that's just an example of copying an array. And when you return an array, you probably have to copy it. Because if you just expose a pointer to an internal array, the consumer can change the array, and we run into even security issues with APIs that don't make a copy when they return an array. So you have to make a copy. And then arrays tend to get large, and copying it is an expensive operation in some cases, correct? So I think I don't have a slide now illustrating the problem, but people have this common pattern of iterating over the array in a for each loop or in for loop. And inside the loop, they would call, foo my properties, open bracket, I, and to get the first property. Then next iteration of the loop, they would call foo.properties, open bracket, I gets the next one, and so on and so on. Each time, foo.properties would create a new array. You can imagine that causes a severe performance problems. And when something is a property, code that looks, foo.properties access I doesn't look too bad, correct? The moment you rename the member to be a method, to indicate that it's a method and actually change it to a method, the member would be foo.getProperties, open bracket, close bracket. That would probably kind of send a hint to the developer that this is potentially an expensive operation. I should cache the array and then iterate over the array. I thought I had a slide on it. If I have later, it will be probably clearer. So again, I'm not going to go into all the details, but we have many patterns that people expect seeing in the framework. So for example, how you design attributes. It's very well specified in the design guidelines. So attributes have kind of two different parameters. They're not parameters, but parameters in quotes. They are optional and required, correct? And the required become constructor parameters and get-only properties, and optional become get set properties. So this is an example of a pattern, and people expect attributes to be designed this way. And if you wanted to design attributes the other way, or any other way, there are many ways to design attributes, but that's what they expect. Same with exceptions, correct? So we have a pattern that says exceptions should have this set of constructors. Developers just expect, for example, an exception type to have a constructor that takes a string message. They just expect it. If you don't have it, you sooner or later run into problems. And again, most of the guidelines are illustrated with problems that we ran in the past when we try to violate our own guidelines. So we ran into a lot of cases where we thought, oh, we had this guideline for 5 years, it worked pretty well, but we discovered this small corner case where actually we would like to violate our own guideline, the BCL team. The most recent one is from .NET Framework 2.0. So we have a guideline that says no public fields, correct? We designed the new collection APIs in the generic collections namespace. And one of the design goals was to optimize performance, like really, push the limits on what we can do in terms of performance of collection APIs for some of these, like list of T and dictionary. So there are many improvements, and they are still there in the APIs. Like we removed all virtuals, and we enumerators as tracks, so they don't allocate objects on the heap, and so on and so on. One last one that we wanted to do is to change the properties on key value pair, the element that sits in the hash table in dictionary, from fields to from properties to fields. And we said, okay, we're gonna change it, and also we're gonna change guidelines, correct? So this is how convenient. So we decided that it wouldn't be a bad guideline if we said, if it's a small data structure, it has no operations, correct? It just has, it carries 2 fields. Why don't we allow fields? You have a constructor, the only thing that constructor can do is set the fields, and then you read the fields using the fields syntax and not through properties. And it seems like a very reasonable guideline, correct? We would not introduce guidelines just to do things that are completely unreasonable, correct? This sounds very reasonable. Anybody kind of disagrees? Yeah, so we thought so. So we designed this dictionary using fields in this very simple data structure.
So what's the overhead of adding the property in this case?
So when the question is, what is the overhead of accessing a property? It's extremely small, and inliners often turn it actually to access a field. There are cases where the inliner cannot do it, and then you have some overhead. But the design goals for these were, let's push the limit to the very end of what we can do in terms of performance. Correct? We wanted to basically list of T to be as performant as array. And it's not there, but we think we got it to a point where it's as close as you can do with kind of a bit more higher level abstraction. So we designed this dictionary key value pair to have fields, and it was in the last milestone, I think. The next milestone, we discovered that it doesn't integrate with the data binding. So data binding, you guys know what data binding is? It basically, it allows you to take a collection, assign it to a control, and the control knows how to get the data out of the collection and show it. So list of T can be shown in list views by just assigning it to a property. You don't have to actually iterate and manually put the items into the list view. And dictionary has a similar integration with some more complex visual controls. So, of course, we checked in the code at the end of the milestone. And then next one is the, just DCR milestone where you have to, go through wars and justify every single change. And we discovered it doesn't work with data binding, correct? Data binding assumed that everything is a property because there were no fields in the whole framework. The moment you introduce something different, you kind of, you may expect to have problems. And that's another thing when I often review APIs. and teams come up with something that is very clever and seems to improve locally the component, I often don't even know that they're going to run into problems. But I tell them, hey, I ran into many cases where it was ultimately a problem, and it was very difficult to fix late in the product cycle. Moreover, not only in this product cycle, you would think that data binding can be fixed in the future to accept fields. But it's often extremely expensive, and often it's prioritized low because, hey, 20,000 collections in the framework use properties. You are the only one that is using fields. Why would we change data binding to kind of cater to this one API? So this is an example of kind of, changes in the patterns are extremely expensive.
So you roll back the change in that case?
Yes.
Did you roll back the guideline too?
Well, so we didn't publish the guideline. We were just thinking about this. At some point, I started to be very hardcore about what we add into the guidelines. I kind of treat changes in the guidelines as almost as changes to APIs, being kind of breaking. And I think it's required. If you work on guidance of things that cannot change, you cannot tell these people who design the things that cannot be changed to change them because you change their own guidelines, correct? So we are being very careful about what we add as kind of official guidance. We often have kind of internally we talk about, hey, this is the guidelines, let's start designing the framework based on the unofficial guidance and see how it goes. If it proves itself, then we will add it officially as a guidance. So yes, the design guidelines are kind of, they are all well-tested concepts. It's not like, we come up with, a new guidance today and tomorrow we tell everybody in the world to design APIs this way. That would not work. So XML, we have guidelines for how to use XML APIs and so on. Async pattern, which is how do you design asynchronous APIs, correct? There are like hundreds of different ways to design it. And dispose pattern, which is a pattern for deterministically cleaning resources. And here another example, like dispose pattern seems to be like you can tweak it. Correct? So the dispose pattern says that you have a method dispose, and then it calls a protected virtual method called dispose boolean. I mean, boolean is the parameter. The boolean tells you whether you're running from a finalizer or from explicit call to dispose. And finalizer is the GC thing that calls the dispose method automatically for you if you forget. So it seems to be like, okay, I have this protected method. It's actually not used externally. I can actually tweak what I do in the dispose method that calls the dispose boolean, correct? And many people try to do that. Every time you do it, you break something. So, for example, C++ compiler has a very strong dependency on the dispose boolean method. It actually uses it to simulate deterministic disposal of objects. So, like in C++, in the new, I think, .NET Framework 2.5 C++, you can actually declare a local variable and tell it to kind of to simulate allocation on a stack, even if the variable is a reference type. So at the end of the method, they will basically just call the dispose logic to kind of simulate unwinding of the stack. And they have a strong dependency on the dispose pattern. So if you do something, you tweak it slightly, you may break C++ compiler or some other thing. So let me go to exceptions. So I talked about benefits in terms of usability. And here's some of the, I think, elaboration on the subject. But I talked about kind of richness of the information that you can carry with the exception, robustness, and I think one of the more important things is that they are required, correct? You have to, you cannot just say, hey, I don't care about this error condition, I'm going to just keep going. You at least to have explicitly catch it, and some people swallow exception. We kind of advise not to do that. But it forces people to think about error handling of their code. So what are the guidelines that we have? One of the problems with the current framework is the number of exceptions that we introduced in the APIs. So when very often people ask the question, when do I create a new exception? Correct? Should I just reuse an exception that is thrown from the framework or create a new one? And the way I like to think about the problem is I divide exceptions into kind of two groups. One is a developer error, correct? Exception, you would like to throw an exception because a developer made an error when they code to your APIs. A good example would be a null argument exception, correct? Like the API says, I cannot accept nulls as this parameter. The developer would make a mistake, pass a null, and the API would throw a null argument exception. Now, this exception can be very easily fixed by basically not passing null to the API. Probably nobody would be trying to address this exception by catching the exception and calling the method again, now passing something else than null, correct? So, and there are many exceptions like that. In this group, the exception type actually doesn't matter. The reason is you never catch this exception, correct? The most important thing in this exception is the error message. This is an exception for developers. This is not an exception for the program to catch and react to. So the developer would like to probably read a very explanatory message telling, you cannot pass null, or the format of the string that you passed is different, so please format the string properly. And they just fix their code, and the program can run without ever throwing exception again. Now there's this second group, what I call asynchronous exceptions, which are not developer errors, correct? Developer cannot do anything in their code to ensure that the exception won't be ever thrown. A good exception in this category is file not found exception. So you would think that you can, maybe check whether the file exists and then access a file, and you would never get the exception, but that's not the case because of races, correct? You can check file exists, then you try to open it, meanwhile some other thread or process deletes the file. So this is an example of an asynchronous exception. And for these, message is important, but more important is the actual type of the exception, correct? Those are exceptions that developers want to catch. When they catch exceptions, one thing they don't want to do is catch some accidental other exception that was generated lower on the stack. So let's say instead of file not found exception, we would be throwing some interop exceptions. And let's say we just had a base type interop exception and we throw it for everything. Now, how do I implement my robust code that tries to open a file and handles the error condition when the file got deleted between when they checked whether the file exists? And maybe the way to handle the exception is to recreate the file. Right? Maybe that's the logic to handle the error condition. Now, if I'm getting some high-level exception like interop exception, I don't know. I may be creating the file, trying to read it again, and I will be getting the exception again because some DLL in the interop layer is missing. But I don't know. I'm thinking that I'm getting the file not found exception. So again, the asynchronous ones, the type is very important, and it should be unique. From a single API, you should not be getting the same exception, asynchronous exception type, for two different error conditions. For the kind of developer error exceptions, the type kind of doesn't matter. And we already have so many types in the framework for most common developer errors, like argument exception, argument null, invalid operation exception, not implemented exception, platform not supported exception, not supported exception, that you should just reuse some of those.
And why do you call asynchronous exception?
It's asynchronous because you can get your program into this error state without you doing anything within your control, correct? So let's say you cannot remove items from a queue if the queue is empty, and you're going to get an exception. That is not asynchronous, because you can lack the access to the queue. Okay, simplifying a bit, it's not asynchronous because you can lack access to the queue. You can ensure that before you remove an item from the queue, you have items in the queue. You are in control, correct? The developer is in the control. Versus asynchronous is developer is writing their program and it's correct program. Something else asynchronously is putting the state of the system in a bad state. So now, performance of exceptions. Very early in the design process of our type system, we decided that we will be using exceptions for exceptional cases. Some of you probably remember we were talking a lot about kind of use exceptions for exceptional cases. So we thought that they will be thrown very rarely, but we knew that people will want to set up the try-catch, finally blocks very often, correct? So you want to write a program to be robust and kind of plan for the rare occasion when an exception is thrown. So we don't want to make this expensive. We don't want you to worry about putting try-catch because it's doing something to make it expensive. But we thought that exceptions will be thrown very rarely. So the actual act of throwing an exception is very expensive, and we thought it's fine. Now, it turns out that it's a bit of a problem. The reason is that it's in first place very difficult to define what's exceptional, because it depends on the consumer. And for a framework designer, it's extremely difficult. So, running out of memory for a data entry application is an extremely rare case scenario, correct? Running out of memory for a SQL Server is not that rare. And the reason is they basically allocate all memory on the machine, or not even for SQL Server, for some applications that run side by side on the SQL Server machine. So now, it depends on the consumer, it depends on the scenario. In some cases, error condition can be very rare. Sometimes it's extremely common. And performance kind of forces you to design APIs slightly differently and sometimes work around the performance problems. But anyway, this is the type system and exception system that we are stuck with. So you have to think about the performance implications of actually throwing exceptions. I wouldn't worry about this problem too much when you start designing APIs, unless you design something that is very low on the level kind of component that can be accessed multiple times in a loop, and every time it can throw an exception. Examples of such APIs are like parsing APIs. So we run into performance problems with XML parsers, trying to parse a file, getting a lot of, let's say, integers, trying to parse them, getting exceptions for many of those integers in a file because, let's say, the developer expected a completely different file, but the parser wants to continue to the end of the file, and you could get potentially hundreds of exceptions before you actually completed the routine to parse a file. So this is an example where actually worrying about the performance implications of using exceptions completely makes sense. In many cases, in practice, it's not a problem. So if it is a problem, there are some ways to provide APIs to help developers avoid the condition when they get an exception. And we call this pattern tester-doer pattern. So let's say there's a method called doer, which does the work, and it can throw an exception. Tester tests the preconditions for the method. And I was talking about the file APIs, and file exists doesn't solve the problem of not ever getting an exception from file open, because the file could be deleted before those two instructions executed. But it mitigates the performance problem, correct? So yes, I can still get the exception, but if I check whether file exists, now the exception will become very rare. If I don't check, it may be actually very common. If I do check, and there are many techniques that kind of rely on the idea of first checking preconditions. Even if the preconditions are not stable, they can change. It still solves the exception performance problem. So this is how the try-parse APIs are designed. So we had a parse method. It throws an exception. It's not performant if it happens too often. We added a method try-parse that returns a Boolean. And you can kind of look at the API and say that this is an error code. But we have the Boolean that is returned from try-parse. But we are being very careful about ensuring that the Boolean is returned just for one error condition that is very clearly described in the documentation. This is not like, I failed, I'm going to return a false, and you discover what went wrong. This is about a very specific problem. So like the string that you passed is not an integer. This is a trivial case, but in more complex APIs, there are many error conditions. We would return Boolean just for one and throw exceptions for the rest. This is kind of a simple rule of thumb. In a lot of cases, your code should have a lot of try finallys and not many try catches. And the reason is that if you have an error condition, you definitely want to clean up your state of your system, and that's what finally is designed for. Catching exceptions and actually handling exceptions is a relatively rare thing. It needs to be thought through. It needs to be well designed. There are still a lot of cases where even software that tries to be very robust has to basically let the exception propagate to the very top of the stack. And it doesn't have to be the very top of the process stack. Maybe like an add-in would let an exception propagate, and the host would kill the add-in and create a new one. So for example, ASP.NET does that. So when we see code that has a lot of catches, we sometimes wonder whether the developers are not swallowing error conditions that they have no idea how to actually handle. Don't catch and eat exceptions. There's this idea of many people think that they can catch an exception, log an error, and rethrow the exception, correct? Now, the first thing you would point out is that, the first time they do it, they actually do catch exception E, and then they say throw E, correct? And that clears the stack trace of the exception. So throw E basically restarts the stack trace from the throw E statement. So you had an exception thrown somewhere high on the stack. It propagated, got caught, logged. Now it got rethrown. now the stack goes from here. So you don't know what happened actually, which method initially threw the exception. So the next thing the developers learn is that they can actually use the throw statement. So you just say throw, semicolon. And that actually seems to be rethrowing the exactly same exception. So it seems not to clear the stack. And people say, oh, perfect solution, this is what I will be doing. Now there are two problems with it. One is that it's very problematic for debugging. So in a debugger, you can actually set an option to break when an exception is being thrown. And what happens in code that kind of progressive, like throws an exception and catches logs on the whole stack, you get basically interrupted by the debugger all the time. Second problem is that it actually clears the stack to some extent. So the thing that is getting preserved by throw semicolon statement is the textual representation of the stack. When an exception actually propagates the first time, we have the stack on the stack. We can inspect variables and so on. We can do everything that you can do with a stack. The moment you catch an exception, the stack actually unwinds. What we do to preserve the stack trace, we capture a textual representation of the stack. And that's why it appears that the stack trace is not cleared. But it is, and in majority of scenarios it doesn't matter, because in majority of the scenarios you are interested in the textual representation. You just want to know what's the origin of the method that threw the exception. But the moment you want to inspect variables and so on in the stack, it's not there anymore the moment you say catch. So that's another kind of disadvantage. And this lists some other mistakes like catching and returning booleans, which kind of defeats the purpose. Or go ahead.
So I'm wondering, I see a lot of prescriptive guidance to never just catch, the system.exception. And I'm wondering if it would have made more sense from the .NET framework perspective to not make that possible, since it could be, potentially something that inexperienced application API developers would end up doing a lot anyway.
Yes, well, so we thought about. So this goes back, there was a question about why don't we make it a warning in the compiler to have a property that is a single word. And I think this is a very similar. We don't want to put constraints in the engine, in the type system, in languages. As you go to the bottom of the stack, we want to put less and less constraints that are not as baked as this layer of the system. So we think that the very lowest layer of the system, the type system of the CLR, will last longer, potentially much longer than the exception system that we have today. So we definitely don't want to put these low, kind of higher level concepts as constraints in the low level system. But we did think about separating exceptions formally into those two groups of developer exceptions and the asynchronous exceptions. And this is similar to the Java kind of errors and exceptions, correct distinction between those two. So that was one way of we thought, okay, we have a concept of exceptions, let's split the hierarchy, and then maybe let's have higher level tools, again, like fxcap. Or maybe language compilers. We don't know yet. We don't want to bake this concept into the engine. Compilers is kind of the next layer. Maybe they could build in features that kind of made the split between developer and asynchronous exceptions explicit and kind of prevent people from catching ones and so on and so on. So I was talking about kind of the constructor exception constructor design that is expected by developers, and this is in the full glory. Basically, all exceptions should have the default constructor, this message constructor, and one that takes a message and an inner exception. And then serialization constructor for serialization, and all exceptions should be serializable. Now, that does not work in a lot of cases, correct? So you have an exception, let's say it's an exception that we throw when an WCF message is malformed or something like that, correct? So you would like to have an exception that takes the message as a parameter, expects the message, and produces a message string that is auto-generated from the kind of from the object that was passed to the constructor. Now, again, we try to do this optimization in several places in the framework, and we did run into cases where it was problematic. For example, I remember, we have an exception called, I think it was argument exception or argument null exception, or argument null exception. So all exceptions take this first parameter, which is a string, and it's a message. Except in argument null exception, this first parameter is not a message. It's the name of the parameter that was null. So we thought, oh, how clever. Instead of every single developer who wants to throw the exception has to create a message called parameter foo was null, you cannot do this. They would just pass us foo, and we would like put it into the formatting string parameter, open bracket, 0, blah, 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 is null, you cannot be null. Great idea, correct? So what happens is that developers would still pass us the whole message to this method. And then we would get a lot of exceptions thrown from the framework that would say, parameter null, correct? So we would basically inject their message into our message, thinking that the thing that we inject is actually a parameter name. And yet again, an example of the whole system works this way. These are the conventions. These are the guidelines. The moment you try to be, clever, it sometimes doesn't work. Which I was thinking about this problem, speaking to people in research. This is what you do, correct? You try to do new things, and many of the guidelines are kind of saying, hey, whenever you do new things, be very careful. So I don't know how it kind of how applicable some of the guidelines are to what you do. This is basically illustration of the problem and kind of a small interaction between the developer and the architect, asking the developer, so why didn't you follow the exception pattern? And it doesn't apply in this case. I see why not, because 90% of the time the message is actually not used. We want the parameter name, and that makes it easier for this exception to create the exception message. And now my computer is thinking. Okay. So, and the architect points out that there's the difference between optimizing locally and optimizing for kind of the global consistency of the framework. So this is continuation, illustrating the problem where a person would create a new argument null exception, throw it, but pass the whole exception message. And the last line, or the second box, shows basically what the result of the operation would be, and that's not what the developer intended.
Do you guys respond to that by just checking whether the string that's passed as the parameter name conforms to the rules for an identifier, and if it doesn't, treat it as a string and don't use it as a substitution? I mean, you could solve it on your side, is what I'm saying. Yeah. By verifying it.
Performance.
Yeah, I know. But in a common case like that, it seems like, I mean, you're already screwed because you're doing exception handling at that point. You're unwinding the stack. Yeah. It's expensive anyway.
No. So string comparison manipulations in things that are verifying arguments for an error condition that happens, rarely. That's probably wouldn't work. if you take into account all the perf implications. Yeah, we in fact are thinking about how can we decrease the number of validation logic in the framework. So, APIs could be much more performant if they didn't verify all the parameters. Just try to do what they are designed to do, and kind of if it fails, well, if it fails in a consistent way, you get consistent message potentially. If not, too bad, correct? APIs could be designed like that, and people designed APIs like that in the past. And in the framework, we decided early on that we will check all input parameters. And we would do as much verification as possible, maybe stopping at the point where we have to parse strings. Now we are thinking about how can we actually remove some of these things. So, there's a lot of research in the, it came from the research group, the SpecSharp, correct? SpecSharp does some of the, what we do with validation of arguments does kind of at compile time. We do validation of arguments at runtime. So we are looking at it because it is impacting performance for very low-level APIs and types. So now, a short quiz about consistency. Is this going to compile? Who says it's going to compile? Nobody. So that's the power of consistency, correct? When I ask the question, like, will it compile? 95% of people or more say it won't. But the answer is, it depends what FIFO is, correct? It could be a class or an interface. And it's a bit twisted, but it shows how much people rely on consistency when they think about APIs, correct? Like many of you probably didn't even think like, oh, it says FIFO, no, you cannot instantiate it. And that's great. The problem is, the moment you tweak something, change something, and you depart from what people expect, it causes a lot of problems. Correct? This one is good. Your thinking was good. You can now imagine how it would throw you off, kind of when it was something that impacts how your software works. For example, if somebody used IFU as a name of a class, correct? In some scenarios, it could actually confuse the users. And we do have, unfortunately, some types that start with I, because the identifier starts with I, and people sometimes do confuse them for interfaces. I now cannot remember why would second letter be an uppercase. But there are some cases. Maybe it's not even second letter. It doesn't have to be even uppercase. It starts with I. Visually, some people kind of get confused, thinking that it's an interface. Oh, I see. I now remember. It's in a list. There's one namespace where we have a lot of types. They start with I. All of them are interfaces. And in the middle, there's a type that starts with I, and it's not an interface. And a lot of people kind of visually look at the list and say, oh, all of them are interfaces, great. And they go and program, and then they discover that the one in the middle is actually not. But kind of when you do things quickly, you may not notice. And that's too bad. We cannot do anything about this one. But don't do it kind of on purpose. Don't depart from the conventions. So again, the power of consistency. This is why you thought you're not going to be able to instantiate the type. So the last principle is designing APIs so they can last. And here the kind of, I would call, naive approach is to go and think, what are all the things that will change in the future, and try to anticipate them and design the API to kind of accommodate the future. And I said it's naive, maybe it's a bit too harsh. Sometimes this is the right approach. But it's only a good approach for in specific cases where we really know what we will be doing in the future. I would even say, if you don't have the future APIs designed, maybe there's like a schedule pressure, and you need to ship part of the component today, and you're designing this component to be extended in the future with something that you already have designed as well. I think that's fine. That's fine way to kind of ensuring that the APIs will last longer, and then that you will be able to add this additional feature in the next release. You cannot do it for things that you are not sure about that you will be doing, and you probably will fail if you haven't actually designed the API in the same release. So what do we do, correct? Like, do we even think what's going to happen in the future with APIs? So I think that the way to ensure that APIs last is not to anticipate exact cases of extensions that we will be doing in the future, but rather design API to be generally extensible. Correct? So there are ways to design API to make it less evolvable or more evolvable. And I'm going to go through some of the cases. So one is interfaces versus abstract types. And that's one of those that also was quite controversial not so long ago. But now it seems like it resonates with more and more people designing the frameworks. So basically, we advise that unless you have to make something an interface, you should opt for an abstract class, or class in general. And the reason is the way you can evolve abstract classes or APIs based on abstract classes versus APIs based on interfaces. And I have an example. So the kind of root of the problem, it's probably obvious, but the root of the problem is you cannot add members to an interface. Correct? Once an interface ships, if you add a member, everybody who implements the interface will have to implement the member. But the types that implemented the first version of your interface would not implement the second version, the additional member that we added to the second version. So if a concrete type implementing interface version 1 loads into a process that has interface version number 2, the loader will fail. Will say, you're not implementing this additional method that I require. So this is how we designed stream abstraction in the .NET framework. So in many frameworks, streams are interfaces. We chose to design it as an abstract class. And we shipped it in V1. And then we thought about adding timeout to streams. So we wanted to be able to specify a timeout, and when you read and the timeout expires, we will throw an exception. Now, this is how we did it with the abstract class. We basically, in the .NET Framework 2.0 time frame, added a property called read timeout. So you said, I'm willing to wait for a second or 2 seconds. We added a method called canTimeout. And this is similar to the tester. Correct? So you're supposed to interrogate the stream whether it supports timeouts, because by default, it won't support it. Correct? We added this method, the property read timeout to the abstraction. Many concrete types won't actually override this property, so they will throw not supported exceptions from the property. So if you don't want to get exceptions, you can actually interrogate the canTimeout property. And file stream implemented the new stream by basically overriding canTimeout and saying, yes, I do support timeout. Correct? I added this functionality. And read timeout property, the getter just returns an integer. The setter actually sets an integer that then we use when we execute the read operation. Now, this is how we would have to design it if we base the stream APIs on interfaces. So let's assume we had an interface iStream in first version of the framework. We could not just add new methods like read timeout or properties to the interface, because we would break everybody who implements them. So what we would have to do? we would probably add a new interface. That's a common technique from other frameworks. We add a new interface called stream that can time out. It probably would extend iStream, kind of for convenience, or it wouldn't even have to do it. And then we would implement this new interface on file stream. And now we don't need this method can timeout because you can do it by basically querying the interface, correct? So you ask the type, hey, do you implement iTimeout enabled stream? If yes, I can set the property read timeout. If you don't, I don't have to. So now it seems like both options are roughly equivalent. Maybe this one is even better because one less property. We don't need this can timeout property. So what is the problem with that one? The problem is, the very root of the problem is the dynamic casts. So to interrogate the object whether it implements some interface, you need to do a dynamic cast. Unless you already have a reference to this interface. But as this example shows, you often don't have it. So you have to do a dynamic cast. Dynamic cast is this as statement. Dynamic cast is not very well known. It doesn't show in Intellisense. And people don't understand the difference between as and is, and they get exceptions and whatnot. And now, is it clear why they have to do a dynamic cast? Because as I said, if they instantiate a file stream and they have a reference to file stream, they don't even have to do any dynamic cast, correct? File stream implements the new interface. They can just deal with the file stream reference directly. The problem is that many abstractions like stream, they actually are not things that, and even subtypes of abstractions are not things that people instantiate and use, and then the method exits and that's it. Those are things that you kind of pass around. So for example, stream is passed around through methods like reader.baseStream. BaseStream returns a stream. So now to access this additional interface members, you have to downcast stream to iTimeout enable stream. And that's a very common thing in APIs. Abstractions, you often, they are viral, correct? You introduce an abstraction to a system, it shows all over the place. Now, if your abstraction is in interface, you cannot change it. So all over the place, you stuck with iStream. Now you introduce a new concept of iTimeout enable stream. How do you propagate it through the whole framework? You cannot. You cannot. So the way you do it is basically you propagate the object internally that implements this additional interface, but users have to manually downcast to the interface to access the additional features that it provides. So this shows the code sample and the problem. Now, this is how it actually works with the APIs based on classes. So as you saw on the previous slides, we added a property called canTimeout. And people can just check the property. If the component implements timeout, they can set the property read timeout. It's all properties added to stream. So you remember stream kind of propagated all over the framework. It ended up in the streamreader.baseStream. But it's a new stream, correct? Suddenly it has new members. It's all compatible, and it's all very usable and visible for people who use Intellisense to kind of discover new features. Was that kind of... I can forward the slides if you kind of work the examples. You can...
So is that a pattern that you're going to include, that if you want to extend your base abstract class, that you always have a corresponding can property that goes with every extension that you want to add to it, because it becomes a pattern, really?
Yes. So I think now I don't remember, we ran into cases where it was actually not required to add this tester. I forgot now how it works, but I think that basically the doer property was expressive enough to kind of, or you don't mind exceptions, or actually exception is the only way. It's asynchronous, so even if you add the tester, hey, you still have to handle the exception. Performance is not a problem, so why don't you just have an exception? But in majority of the cases that we use this pattern, yes, we basically added can something, can I do this new thing? We tried to do some variations on the pattern where we added a lot of new functionality to an abstraction. And then we had a single method that tells you which of the new functionalities is supported by a subtype. So let's say we added, timeouts, transactions, and whatnot to files. We could have a single method, like query, do you support operation foo, bar, and so on and so on. You pass some enum. So we experimented with these APIs, but this is the one that we use most often. And like 95 or 99% of cases use it. So what is the other way to kind of ensure that your API can evolve in the future? And I was saying, prepare your API for extensibility, kind of general extensibility. And it may sound a bit contradictory, but preparing APIs for future extensibility often means limiting extensibility. It turns out that the more extensibility you add to your APIs for kind of for consumers of the APIs, the less flexibility you will have in evolving your APIs. So this is an interesting trade-off, correct? You create a type, you make it very extensible for your customers, and you say, like, now you will be able to modify, every single thing that my API does. In a lot of cases, that locks you into you paint yourself into a corner. We ran into this with the array list APIs. So array list is a collection from V1 that roughly corresponds to list of T, and every single member on array list is virtual. So we said, hey, like if you don't like how we implemented array list, you can override the member, you can do whatever you want with it. And then when we were optimizing list of T for performance, we said, hey, we would like to do some of the same optimizations on array list, correct? Why don't improve array list as well? It's already in a lot of people's code. We would get performance improvements in many apps kind of magically. So we tried to do that, and the problem is the moment you have a virtual member and it calls some other virtual members, you start running into like order dependencies. There's also this interesting problem that parameters of non-virtual members can be kind of opened up. You can start accepting more data, correct? So let's say we had an API in first version of the framework, and it would have a parameter that is an integer, and it accepts values from 0 to 5. We could start accepting parameters from minus 200 to 1,000 in next version. Not a breaking change, correct? The moment a member is virtual, its parameters become both in and out things, correct? They are not in only parameters anymore, because they are in from the perspective of the caller, yes, and they are actually out from the perspective of the person who overrides the member. So this is kind of related to the Liskov principle, correct? You can, like, in parameters, you can expand the range. Out parameters, you can kind of narrow the range. You cannot do the other way. The moment you have virtual members, in parameters become both. They are the inputs and they are the outputs, depending who you look at. From whose perspective you look at the parameter. So, for example, having a lot of virtual members, it does paint you into the corner. Like in the future, in the next version, you will be able to evolve your API less. So we have a lot of guidance talking about kind of controlling extensibility of APIs. So like virtual members, for example, we were very kind of flexible into people coming to the review and saying, hey, we want this to be virtual because blah. Now we are kind of more diligent about testing the extensibility. Like if you designed an API to be extensible, be virtual, you have to basically show us that you have tests. And tests of extensibility don't mean you only show us types that override the functionality. You actually need to show us that we have consumers that consume the API through the abstraction, correct? So it's even more applicable to like interfaces, which basically introduce a bunch of virtual APIs kind of almost automatically. The concept is like if you introduce an interface, it's not enough to implement the interface on 5 types. You also have to have API that actually consumes the interface. So like one concrete example where we made a huge mistake is the iClonable API. So iClonable is an interface. It seems like a simple interface, has a method clone. We implemented it on like probably hundreds of types in the .NET framework. We thought, wow, great, you can implement it all over the place, so it must be a good interface. And well, guess what? The interface is now obsolete. Like we didn't put the obsolete attribute on the interface for logistical reasons, but like our design guidelines basically tell people not to implement this interface anymore. And the reason is we didn't have even one API that actually consumed the interface. Correct? Like we only had types that implemented it, but now nobody actually consumed it. So in itself, you could say, well, too bad, you have an interface that is completely useless. Now the problem, so why don't people use the interface? We discovered a fundamental flaw in kind of the design of the interface and kind of the concept of clonable interface. One is, if you clone, and, well, first, there are 2 different ways of clone. There's this shallow copy and deep copy. They seem to be very similar. They are both copies or clones. They are fundamentally different from kind of the implications on the system, correct? If you have a deep copy, you kind of can make a copy, and you know that by changing this copy, you're not going to affect anybody. If you have a shallow copy, then it's extremely complicated. It depends what the copy is. It may affect this part of the system or that part of the system, or it may not affect anybody, or this operation might affect somebody, this doesn't. So shallow copy, you actually have to understand the implementation of the copy operation to know what it does, correct? So now, implementing deep copy is extremely difficult. Not many types can do it. Many types have references to abstractions. They actually, unless they implement iClonable, they don't know how to copy them. So almost nobody implements iClonable as a deep copy. It's almost always shallow copy. So again, going back to what I was saying, the moment it's a shallow copy, you actually don't know what this operation does if you call it through the interface. Because you have to know the exact type and to know what it does. If the type is a list, you know that it copies the internal array in the list and the wrapper object that is the list. It doesn't copy the elements in the list. That has a huge implication. Versus if you call copy on an integer, it copies the integer, correct, or a string. So you actually have to know the type on which you call the method clone, which makes the interface completely useless. You would never call it through the interface. You don't know what it does. So anyway, that's kind of diverging a bit, but the point is you have to control extensibility. You have to limit it unless you have a very clear case where you need extensibility, where you need abstractions. You need to have tests that show that the abstraction is valuable, that can be implemented on more than one type, that can be consumed in a useful way, and so on and so on. And same with kind of limiting the surface area, correct? So as we go from public visibility to protected, internal, private, you get less and less kind of flexibility and power, probably, I'm sorry, in the APIs. But but it allows you a bit more flexibility in the future in evolving. The extreme case is internal APIs, where evolution is, it's simple. Nobody can be accessing these APIs unless they do like private reflection, which they shouldn't. So we change internal APIs all the time. And then you go to protected APIs. They are a bit more flexible in evolution. And of course, the public ones are the least. Many people take dependency, and it's very difficult to evolve them. And here it seems like this kind of visibility problem may be very obvious and simple, but we have seen a lot of cases where people made APIs public kind of accidentally. And I think, again, the reason is history and maybe consistency and patterns. So public in C programming, correct, doesn't mean everybody can access my variable, correct? It only means things in this module, usually. Like if you want to make something accessible externally, you have to export the API. Now, when in kind of the early days of .NET programming, the mental model that people had is, yeah, exactly, I make everything public, that means I can access it, and then I have to do some tricks to make it consumable to everybody, which is not the case, correct? So public in kind of classical Win32 programming is something completely different from public in .NET, yet they have the same name, and it caused a lot of problems. And kind of the last technique for limiting extensibility is probably many of you have heard about the template method pattern, correct? Where you can actually, you create a method that is not virtual, that sets some constraints on what can be, what behavior can be changed. So usually the template method would call some logic that cannot be overwritten, then it would call a virtual member, maybe some more logic that is very static, and then maybe another virtual member. And it would clearly communicate to the users or extenders of this API the two things that I called, those two virtual members. This is code that you can change, correct? The code that I wrote between the line, the order in which the virtual members are called, and so on, is fixed. I own that. So if you look at, for example, I was mentioning array list, everything is virtual. List of T, nothing is virtual. That's mainly for performance reasons. But then we added types, collection of T, read-only collection of T, and keyed collection. Those are intended for kind of the extensibility scenarios. Still, we did not make all the members in these collections virtual. We just made 4 protected members virtual that are called whenever an item is added to the collection, replaced, and so on when the collection is cleared. So people can implement some validation logic and kind of common scenarios that we knew about and we've seen in the frameworks. People actually did these scenarios as opposed to leaving like the count property virtual and letting people override it and introduce security holes where a malicious abstraction, a malicious collection would say, I have 5 elements. Our code would say, okay, 5 elements. I'm going to just iterate 5 elements. But then it would return actually 2 elements and would confuse the system, correct? So this is what you can, these are the problems that you can run into if you allow kind of unlimited extensibility. Versus extensibility that is very targeted and kind of designed in for scenarios like validation, it's definitely the kind of smarter way to go in a lot of cases. So this is about testing abstractions and just formalizes the guidance about both implementing an interface and testing it by consuming. This is an interesting quote that I thought it's very applicable to design problems related to extensibility. In many cases, we design those elaborate extensibility APIs, then it's time to ship and we kind of wrap up things quickly. And what we discover is that in the next version, we actually want to do the extensibility right, but it's kind of too late. So a big problem is being able to estimate how much design effort and time it takes to create a truly good extensible API, and don't add it to the framework unless you're absolutely sure this is it. As I said, changes to APIs that once shipped are very difficult. So this is kind of the end of the session, talking about kind of principles and guidelines and illustration. And we can go to quickly to the next section. It's very short, and it talks about kind of what is the actual process of API design that we use when we design the framework. So kind of on a high level, when we were doing API reviews for WinFX, and it was called LAPI before, and now .NET Framework 3.0, we often saw teams that were kind of average. You know, APIs, no API is perfect. It was kind of average level of quality. Some were really bad. That was rare, but there were really bad APIs. And then from time to time, we saw those great APIs. I mean, this is like, you know, a design that, you know, master API designer designed it. And we were thinking, like, how did it happen? Like, we don't know these people. You know, what is the, you know, silver bullet? How did they learn how to do this? We wanted to know kind of the history. So sometimes we talk with the teams. And then we discovered the pattern. The pattern is all teams that created great APIs had a person whose role was to be the API designer. Correct? So you can create bad APIs if you, like, I don't know, have a very difficult problem or people who don't care about API design or whatnot. The average APIs were created on teams that work like average team, which is concentrate on, you know, the features, the implementation, how the operating system works and whatnot. And then APIs are kind of, you know, then we will look at the APIs and maybe fix it here and there, and we will make it kind of consumable to more general consumer. And these great APIs were created on teams where there was always somebody who said, like, I own API design. I'm responsible for it. I'm being, you know, measured. On my performance depends on the API design, and so on and so on. So then we started to basically advise teams to choose somebody who's responsible for the APIs. It doesn't have to be a separate role on the, well, it doesn't have to be a separate person on the team. It can be just a separate role. So a developer can be a pretty good API designer. Though there's this problem, like, why do we have testers and developers as separate roles? To some extent, you run into same problems when you have developers and being the people who write code, implementation, and people who design the API service. But many developers can, when they design APIs, kind of put the API designer hat and say, now I'm just API designer. You have to resist some kind of urge to use your prototype implementation as the API and so on and so on. But some people can do it. So why do you need a separate role? And kind of maybe separate hat of API designer? API design and implementation seems to be the same, correct? They need to be simple, integrated, consistent, versionable, and so on and so on. But there's different kind of level at which you look at these two problems. So the similarities are kind of superficial. So when you design APIs, initially, you want the design to be extremely easy to change, correct? So the moment you start like prototyping and implementing, changing API surface has a ripple effect on the whole implementation, and people kind of resist doing this. So one of the things that we started to do is kind of creating API prototypes without implementation at all. Sometimes we do it on paper. Sometimes we do it in code in C#, but we just return nulls or basically have like stubs, method signatures, and some implementation, so it does compile, and we can actually start running compiling code samples and testing the APIs, how they feel, how they look, but don't have any implementation, correct? This is not the prototype that then you tweak to arrive at good API. And as I said, this is kind of common distinction between design and productizing a design, which kind of work on different levels. So the design needs to be explicit, and what it often means is that you have to realize it's not free, correct? So a common mistake in the design process is say, okay, so we need to have an API designer, you're gonna be the API designer, and okay, you do what you've been doing so far, and in addition, you do API design. And what happens is that this never works, correct? I was recently talking with people, and I said that I think there are two ways that something happens at Microsoft. One, it's your explicit goal, and it's incorporated in your schedule, and you can tell your boss, sorry, I cannot do this other thing because I'm doing this thing that is on my goals. Or it can be like a special push, correct? We do security pushes, or performance push, or UI consistency push, where like every team member stops doing what they are doing and they do this new job that is just for 2 weeks, correct? Those are the only two things. The kind of projects after hours, the projects kind of after hours, you do this thing, whenever you have time, this is your additional responsibility. They can bring results, but it takes a very long time. It's not comparable with a milestone when we design API components. So, for example, the design guidelines were kind of started as an after-hour process, but it took us like 3 or 4 years to get them to a stage where they were really useful. So if you have 5 years to design an API, it can be kind of after-hours weekend job. If it has to be compatible with the schedule of kind of release and designing components, not only the API surface of the components, it has to be an explicit kind of thing that you know how to pay for in the schedule. So I was showing, so then API designers identify the scenarios, they write the code samples, I was showing that. From the code samples, you can derive the actual object model, which is just the skeleton and kind of pseudocode. As I said, optionally, you can kind of tweak it to return nulls and maybe throw exceptions in some places and actually get it to compile. At this point, when you get it to compile, you can actually start running fxcap and other tools on top of it. You can actually start writing tests, which is also very interesting. So we kind of do that. After that, we do these API reviews that I mentioned. So API review is basically, we take the code samples and the API listing, the kind of pseudocode, and we create a Word document. We send the Word document around and we ask people to comment, and we use the Word doc comments. And we have people from different specialties, from usability engineers, performance, architects, and so on, and people just comment. Then we schedule a review, and we kind of walk the comments and talk about the comments with the teams who design the APIs. This is the API listing, this kind of pseudocode. And this is not unusual to see so many comments. In fact, this is not that many. Like many important APIs have a comment basically by every single line of the listing. So for kind of important APIs, core APIs, we do a lot of reviewing and due diligence. what's also interesting, and we do have a tool. So if you have your implementation or the kind of stub-based code that does not yet have an implementation but compiles, you can actually generate this listing using a tool that we have. The tool is called TextRef, and if you email me, I can point you to this tool. So you can run your assembly through this tool and get a listing like that. You don't have to type manually all the method names and get everything 100% right from memory or from specs. So,
could you quickly comment on, maybe it's too long, but that particular class is sealed.
Yep.
Do you have any short comments on sealed?
Okay, so let's go to questions, because this is the end of the presentation. And the first question is, what is the kind of guidance, or if I could comment on sealing types? So the official guidance is that you shouldn't seal types kind of by default unless you have a good reason to. And a good reason is not, oh, we didn't design this type for extensibility. So now I was talking about kind of limiting extensibility, but that's extensibility of kind of overriding methods, and that's very dangerous. So we do recommend that people seal virtual members when they override them. And so when you override a member, you can actually seal, so subsequent subtypes cannot override the same one. You can seal members in the middle of the hierarchy, basically. So we do recommend that people do that. Sealing types is actually kind of too heavyweight. So a good illustration is, if you have a type that has no virtual members, or all virtual members are sealed, correct? And let's say you don't have protected members, that's even better. The only thing you can do if you inherit from this type is to add new members. There's no other thing you can do. So adding new members is actually a very safe operation in terms of kind of, in majority of the cases, future extensibility and security and so on and so on. On the other hand, people want to inherit from framework types for reasons that we often kind of forget about. So the simplest one is adding helper members. Let's say we have a component called message queue, and it has a parameter that is the name of the message queue. In many organizations, we talked with architects who said, we want to inherit from message queue, not to change behavior, override anything. We just want to fix the name of the queue. So we would inherit from message queue, create a default constructor, doesn't take the name of the queue, pass a fixed name to the constructor of the base type, give all developers in our organization this subtype of message queue, and tell them use it. Don't worry about the name. You cannot make a mistake passing something wrong. It's always going to go to the queue that we want these things to go to. You can enforce it using fxcap, write a quick rule saying, hey, if message queue shows anywhere in this program, it's a warning, you should be using my company message queue. Versus you have to parse names that people pass to queues to discover whether they make a mistake or not, and pass constants and teach people about constants and so on and so on. So kind of inheriting to lack some property configuration or constructor parameters. Another one is to add helper methods. Another one is to add attributes. So people want to add attributes for various reasons. They cannot do it if a type is sealed. They can if it's not sealed. They want to rename types. And the way to do it is to inherit, give it a new name, and don't change anything. Those are all scenarios that are extremely safe, and sealing the type would kind of block people from doing it. Any other questions?
So I have a question. So like in Office these days, what they do is the customer experience thing where they account like, what menu functions people are using so they can move it to the ribbon and make it more available. Is there anything similar like that for the framework to see like what APIs are getting called the most often and see what types are the most active and stuff?
Yes. So I mentioned about this prototype that we did in Intellisense, kind of trying to make the types and members that are most commonly used, kind of either in bold font or something like that. That didn't work that well. Now, if I remember the reasons, it was like, to some extent, what's important is not binary, but making something bold is binary. And that was kind of one of the problems. There's this concept of my dot in VB. My dot is basically it's a set of kind of static APIs. So you start you type my dot, and you have a short IntelliSense list saying computer, form, diagnostic infrastructure and whatnot. It shows you kind of simplified view of the framework, correct? 5 concepts. And then you choose machine. And it says, event log and environment variables and that. So you kind of choose, okay, environment variables. And then you press that, and it takes you to the API in the framework that actually represents the type that controls environment variables, correct? So it's like, it's a single starting point. It's the equivalent of the start button in Windows for APIs. So this is another thing we tried. But all these things kind of help a bit. And we will be inventing more and more features like that. VB team may be improving my dot. We may be changing ultimately IntelliSense in the future. As API designers, I tell people, like, design your namespace hierarchies properly. Like, make the distinction between common scenario types, advanced types, and that's kind of the best way, I think, to simplify the view of what's important for majority of developers. Okay, go ahead.
So nowadays, there are more and more APIs that are based on web, like Google Maps, some
Yep.
API. So are the design pattern different over there, or is the focus going to be more on those kind of API versus the desktop-based application?
Yeah, well, you're asking an interesting question that I asked myself, but I don't think there are many people who know the answer. So yeah, of course, I mean, more and more people program, the web APIs. Today, the APIs are like to get, pictures from Flickr and, contacts from Messenger and whatnot. And they still constitute like very small part of kind of the application the developer has to write. So for now, I don't think this is the biggest. Like, if I had to optimize resources, I would still optimize for the object-oriented in-process components, correct, that live in the framework. At some point, I believe there will be more and more of these web APIs. And because of kind of, those are remote APIs, correct? You probably will have to design them slightly differently. They don't have a unified type system like we have in .NET, correct? Like users who work with, our web services and generate proxies need to be able to use them, and people who use, JavaScript need to be able to use them. That's kind of why there's a push for the kind of RESTful, simple APIs for many of the web APIs. So we definitely will need different set of patterns, but I think it's kind of too early. I started to work with the Windows Live team on kind of what will we do in this space. I think the kind of common ideas about consistent, we need to be consistent, correct? Everybody knows that. That's simple, but beyond that, what are the idioms of API design on the web? We still know very little about. Any others?
You talked about the naming convention of the namespaces. common elements in the root namespaces and then divide. Is there a guideline in terms of naming the assemblies and their map with the corresponding namespaces? Like there will be assemblies to expand different namespaces.
What is the question is, what is the namespace factoring versus assembly factoring? We try to keep them relatively independent unless there's no reason to keep them independent. So the idea is that we didn't want people to use namespace. So people first start with namespace factoring, and then they think about assembly factoring. And we wanted to avoid the situation where people design the namespaces for the kind of hierarchy and kind of optimizing for discoverability of the APIs. And then they map it one-to-one to assemblies. Because assembly factoring is done for completely different reasons. It's like performance, architecture, dependencies, and whatnot. They have nothing to do with how people learn about types that are in the assemblies. Maybe not nothing, but they have very little to do with it. So we wanted to make the processes independent and then say, hey, and if the assembly factoring follows the same structure as the namespace factoring, that's fine. Then you should just stick to it and not kind of try to rename it to be different because guidelines say so. Right, one last question.
Are the contents of that document pretty much the same as the book?
So, there are two main differences. One is the book has appendices that are like coding conventions. It talks a bit about FXCAP, and the third one is FXCAP, coding conventions, and something else. There are appendices. And that's one difference. Second difference is the book, the editor edited it. I wrote it, so, you know, if you want to read kind of Polish English, I'm, you know, Polish descent, then the document is great. If you want something edited, then the book is probably better.
Well, as far as the guidelines are.
As far as the kind of the content, it's the same.
It's not in the MS Market?
The book? Yeah, I don't think so. So it's published by Edison Wesley, not MS Press. I think MS Market has only MS Press books. Yeah. All right. Thank you very much. Thank you.